लुगा खाल्छु अहिले बेलुका खेर अब अहिले बेलुका कहिले निद्रा लाग्दैन बिहान त मलाई झन् आज ट्याप्पै लाग्दैन किनकि मैले अघि भर्खर उठेको नि त त्यस कारण आज मैले जति सकि पढ्यो भने मात्रै मेरो युटिलाइज हुन्छ टाइम nature. It's you है ना आदर्श एंड आई एम सॉरी कल मैंने बहुत ही कितना कुछ कहा ना इसलिए दिस इज यू है ना आदर्श नो दिस इज निधि गुड लक इमा ओके गुड लक निधि आदर्श इज नॉट हियर निधि मैंने आदर्श को इतना ज़्यादा गाली दिया ना आई थिंक दैट्स व्हाई ही इज़ नॉट हियर नाउ लेट्स स्टडी ऑल द बेस्ट निधि radioactivity of the sample R1 R2 N1 equals to R0 upon lambda N2 is equals to R2 upon lambda if half okay the radioactivity of a sample is R1 at a time T1 and R2 at a time T2 T1 this is at T1 this time equals to 2 T2 T1 and T2 if the half-life of the specimen is T, the number of atoms that have disintegrated in the time T2 minus T1 disintegrated T2 minus T1 is proportional to total number of disintegration disintegrated in the time T2 minus T1 between T2 and T1 okay total number of disintegration equals to A1 minus okay no N1 minus total number of disintegration equals to N1 minus N2 total number of disintegration number of possible disintegration N1 minus N2 R1 upon lambda is equals to R minus R2 upon lambda from here we can write lambda square R1 lambda minus R2 lambda 1 upon lambda square को यहाँ पर lambda गयो cancel from here R1 minus R2 upon lambda the value of lambda T is equals to 1 ln 2 log 2 upon lambda so from here lambda is equals to log 2 upon T half okay so if lambda is there then it is R1 minus R2 upon ln 2 log 2 कति छ multiplied by T. R1 minus R2 T. R1 minus R2 T. क्या हुआ इमा? यस लेट्स। आदर्श और मेरी लड़ाई में क्या हुआ? पता नहीं, हम लोग पढ़ाई कर रहे थे ना, फिर ऐसे बोला कि तुम्हारी वजह से मैं पढ़ नहीं पा रही हूँ, मैंने आदर्श के सब बोला ना, तो आई डोंट नो क्या हुआ, मैं सोई नहीं थी ना, इसलिए मैंने बोल दिया। मैं सोई नहीं थी तो मुझे नहीं पता था, मेरा ब्रेन भी इतना अच्छा से फंक्शन नहीं कर रहा था, तो मैंने बोल दिया आदर्श की तुम मुझे डिस्ट्रैक्ट कर रहे हो, पढ़ाई करने ही नहीं दे रहे, ऐसा कुछ बोला हम लोगों ने। फिर हम लोग गए थे टेलीग्राम में पढ़ने के लिए, फिर पढ़ाई नहीं, और वैसे तो मैं सोई ही नहीं थी, तो मुझे गुस्सा ही आ रहा था, तो मैंने पता नहीं क्या क्या बोल दिया, मुझे भी नहीं पता मैंने क्या किया। वो भी सोच रहा होगा कि मैंने ऐसा क्यों किया। फिर मैंने कहा कि मुझे तुम्हारे साथ पढ़ना ही नहीं, तो मैंने बोला कि मैं तुम्हें रिमूव ही कर देती हूँ, फिर मैंने उसे रिमूव कर दिया टेलीग्राम से। पता नहीं वो ऑल ऑफ ए सडन क्या हुआ, लेकिन इट्स नथिंग सीरियस, मुझे भी कोई ग्रज नहीं है, उसे भी नहीं होगा शायद। कितना वियर्ड है ना, मुझे भी लगा सुबह उठ के, तो पता है सुबह भी नहीं उठी मैं कल रात को सो के ना सीधा अभी अराउंड 1 क्लास तो मेरा मिस भी हो गया। फिर भैया ने मुझे कॉल करके बोला तो मैं 2nd क्लास के लिए गई, तब तक मैं सोते ही रह गई, क्योंकि मैं पिछले कितने दिनों से नहीं सोई थी ना अच्छे से, इसलिए ऐसा हुआ। अभी लेट्स स्टडी, ओके? तुम्हें समझ में भी नहीं आया होगा ना निधि मैंने क्या बोला? कोई ना फ्रस्ट्रेशन होता है एक एक बार। हाँ निधि, बिल्कुल वही हुआ मेरे साथ। ओके लेट्स स्टडी। अभी तो मैं फ्रेश हूँ ना, अभी उठी हूँ, तो इसलिए आई थिंक आज रात में लंबे सेशन तक पढ़ाई कर सकती हूँ। तुम भी पढ़ना। The activity of C14 activity of C14 carbon 14 in a charcoal sample is found to be 1/8. The activity of C14 in a charcoal sample is found to be 1/8. 1 minus 1/8 of the initial, that is 8 minus 7/8 is equals to 1/8 n naught into n naught. This is n naught upon 8, that is equals to n naught upon 2 to the power 3. Find out the sample. Half-life of the carbon 3 half-life चला गया है, तो 5500 into 3, 5500 multiplied by 3, it is approximately 315. 5 1 is away. 5 is 15, 16, 1 10, 100,000, 10,000, 16,500 years. Number of undecayed, I think that is number of undecayed, right? Half-life. ऑल द बेस्ट हर्षिता, अच्छे से पढ़ाई करना। Initially, there are 1000 radioactive elements present in a container, and after 10 seconds, 900 radioactive elements present in the container. Then after next 10 seconds, present nuclei will be. N naught is equals to N naught e to the power minus lambda t. Okay. Initially there are 1000 radioactive elements. Okay, there are n equals to initial, that is 1000 radioactive elements present in the container, and after 10 seconds minus lambda 10. Okay, it is 900 equals to 100,000 minus 10 lambda. So from here e to the power minus 10 lambda is equals to 9 upon 10. 9 upon 10, right? Yep. And for next 10 seconds, n equals to n naught e to the power minus lambda t. Initially it is 900 e to the power minus lambda into how many seconds? Only 10 seconds. And we have to find n, right? 900 multiplied by e to the power minus 10 lambda को क्या लिख सकते हैं? E to the power minus 10 lambda. N equals to the value of e to the power minus 10 lambda को कति सा? 9 upon 10 multiplied by 9 upon 10. So we have 0 से 0 मर गया. 9 1 से 9, 9 to 18, 9 to 9, 9 to 81, 81, 9 to 0, 810 remaining radioactive nuclei. Correct. Correct. Okay, it is n naught is equals to not n naught, here it is n equals to n naught upon 2 to the power n lambda, 2 to the power n cube, half-life 2 t upon t half, t upon t half, n equals to n upon n naught upon 2 to the power n once, na, t upon t half, 2 to the power t upon t half, 2 to the power t upon t half, 2 to the power t upon t half. Okay, tn 2 to the power t upon t half. I don't know what exactly this is. 0.37. 1 upon e1 equal to 0.37 is equal to 37% of the initial. Okay, 37% of the initial, right? Radioactive nuclei in a container is n naught and its half-life is t. The number of nuclei after time t is equals to d half. T is equals to d half, I mean n naught upon 2 to the power 1, that is 2, n equals to n naught upon 2. The count rate of a radioactive source at t equals to 0 was 16,000 counts per second and t equals to 8 seconds. It was 100 counts per second. The count rate in counts at t equals to 6 seconds was. The radioactive source at t equals to 0 was 16,000 counts per second and t equals to 8 seconds. It was 100 counts per second. Initially कति रहेछ t equals to 0 मा activity is equals to 1600 and at t equals to 8 second, t equals to 8 second मा activity is equals to 100 seconds, right? Yep, 100 counts per second. The count rate at t equals to 6 मा सोधेको छ. t equals to 6 मा कति हुन्छ भनेर activity initial 1600 100. What's the ratio लियो भनेको त्यो हुन्छ 16 which is also written as 2 to the power 3. That means 3 half-life. 3 half-life भएको रहेछ. t0 देखि 8 सम्म पुग्दाखेरि t0 देखि 8 सम्म पुग्दाखेरि कति गएको रहेछ 3 half-life. 3 त half-life हैन. टोटल कति गएको छ 8 seconds. 3 half-life. Okay. यहाँबाट हामीले के निकाल्न सक्छ न त हाफ लाइफ कति हाफ लाइफ एउटाको हाफ लाइफको लागि कति हो भनेर भन्न सक्छ. टोटल कति हो भने त 8 हो नि त. अनि डिभाइड हुन्छ. Oh, it is 4 not 3. 16 हो. This is t to the power 4 हो. 4 हो. 1 2 3 2 to the 4 4 4 to the 8 8 1 8 8 to the 16 हो नि त. 4 half life 4 not 3. 4 half life गएको छ हो. चारवटा half life 8 सेकेन्ड भनेपछि हाफ लाइफ कति हुन्छ भने त 8/2. एउटा हाफ लाइफको लागि 2 1 2 2 4 8 2 2 2 2 2 4 2 3 6 2 4 8 यहाँ 4 हो. 4 4 4 4 2 8 हैन. हाफ लाइफ इक्वल्स टु 2 सेकेन्ड्स. एक हाफ लाइफको लागि 1 hf इक्वल्स टु 2 सेकेन्ड्स हैन. 6 सेकेन्ड्समा कति भएर जान्छ 2 सेकेन्ड हामीले कति देख्छ 6 3 half life. No, this is not maths. This is physics. What kind of name is that? It's unique. Now let's study, okay? This is physics and this is really terrible. I'm not good at math, na? Hello, Vishal. I think we should study. If we focus on chat, no, we'll keep on talking. Especially when I go on like that. Let's study, please, 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 please. Let's study, everyone. Half life 2 seconds. We have 2 half life. That means n t half 6. Okay. From here we have 2 n equals to 6 upon 2 because t half for 1 is 2 seconds. 2 ones are 2, 2 threes are 6. N equals to 3, that means 3 half-life. 3 half-life. Initially we have n equals to initial n naught upon 2 to the power 3, right? 3 half-life, yep. That is 1600 upon 8. 2 to the power 3 means 8. 8 ones 8, it was 16. That is now the remaining is at t equals to 6 is 200 nuclei. The radioactivity of a sample R1 at T1. T1 ma A is equals to R1 सा A भनेको के हो lambda n, negative of lambda n, negatively के symbolize गर्छ. Radioactive nuclei is decreasing at T equals to 2. T equals to 2. A is equals to minus of lambda n. T2 A equals to A2 is equals to R2 and T2 मात्र R2 तो समझे ना. If the half-life of the specimen is T, half-life कति हो T हो, the number of atoms that have disintegrated in the time T2 to T1 is proportional to number of disintegration के को बराबर हुन्छ. Number of disintegration. How many hours do I have? One, two, three, 4. 4, 5, 6. Third of 1. Okay, this much. Then we still have 2 more chapters. Number of disintegration, right? Is equals to n1 minus n2. n1 we have R1 upon lambda minus R2 upon lambda from here. Lambda square. R1 minus R2. Lambda square. Lambda 1 R1 minus lambda 2 R2. Lambda, okay, just lambda. Okay, this whole thing is lambda R1 minus R2 upon cancel. The value of lambda from here is T half. ln2 upon T half, which is given T half is equals to T बोला है. So here we have ln2 multiplied by T. R1 minus R2 upon, not upon, multiplied by T. Okay, carbon dating system. We have done it, right? Just right now I just did it. Half-life for radioactive substance for alpha and beta decay are half-life for radioactive substance, okay, 1 upon T effective is equals to 1 upon 1620. Is it plus or minus? It is plus, I guess. 1 upon 405 years respectively. Then the time after which the activity is reduced to 1/4 will be. The activity is reduced to 1/4, okay. First I have to calculate this. Equals to 1620. 1 plus 405. 1 4 4 6 4 12 4 16. 4 4 16. Okay, that means 4 4 16. 4 4 16 0 2 4 4 16. 16 4. 5 upon 1620. 5 5 15 5 15. 5 to 10. 5 was 20. 1 upon 324. T effective is equals to 324. Half-life of a radioactive substance for alpha and beta decay are 1620 years and 405 years respectively. Then the time after which the activity will be reduced to 1/4 will be 1/4. Activity is equals to lambda n. is reduced to 1/4. 1/4. Then time after which the activity be reduced to 1/4 will be activity. You activity reduced by the कति हुन्छ 1/4 भन्ने गरे. Initial upon 1/4 and not upon 4, which is also written as n naught upon 2 to the power 2 to half-life. Half-life of a radioactive substance of half-life कति दिएको छ यो भर्खर निकालेको त half-life हो नि अन्त. Okay, so we have n naught equals to 2 into 2 to the power 4. 2 to the power means 2 half-life. 2 half-life. दुईटा half-life गएको छ भनेपछि T half equals to 324. T half कतिवटा भएछ दुईटा T half भनेपछि एउटाको लागि यति हो भनेपछि दुईटाको लागि हामीले multiply into 2. 4 to 4, 4 to the 8, 2 to the 4, 3 to the 6, 648 years. 2 half-life. 2 into T effective. 648 years. The radioactive material has a life of 600 years and 300 years for alpha and beta emission respectively. The material decays by simultaneously alpha and beta emission. What is the time in which 3/4 of the material will decay? First we have T effective 1 upon 600 plus 1 upon 300. T effective is equals to 600 plus 2, that is 3 upon 600, which is equals to 1 upon 3 to the 6, 200. T effective is equals to 200. But the question is, what is the time in which 3/4 of the material will decay? 3/4 material decay होना चाहिए. Time in which 3/4 of the material will decay. 3/4 and not initial how many? It's not given, right? Okay. The radioactive material has a half-life of 600 years and 300 years for alpha and beta emission respectively. The material decays by simultaneous alpha and beta emission. What is the time in which 3/4 of the material will decay? 3/4 initial time खोज्नु भन्दैछ हैन. Decay initial initial minus remaining, that is n naught is equals n dash is equals to n naught minus n. Undecayed 1 minus 3/4. It's given in fraction. 1 minus undecayed also 1 minus 3/4. This is 4 upon 4 minus 3 upon 4. 1 upon 4, 1/4. 2 to the power 4. And not upon 4 1 because 2 to the power 4. 2 to the power 2. 2 half-life from here. The material decays by simultaneous alpha and beta emission. What time in which 3/4 of the material will decay? And not about 4 equals to half-life. What is the time in which 3/4 of the material will decay when the sun not do it a half-life because हम half-life देखो तर T effective निकालेगा सन तो multiply 2 into 2 effective कति आको बच्चा 200 400 years. Correct. Undecayed 1 minus 3 1/4 1/4. To effective half-life. Nuclear fission. Nuclear fission नहीं होता ना. Helium 4 to fission. Yep, it is fission. So this is fusion. This is fusion, not fission. Fission is uranium 235 92 plus slow neutron 0 1. Slow neutron hits, it becomes 2. Barium and krypton 36 54. 3 and 0 1 plus 200 mega electron volt का एनर्जी ने रिलीज कर सकता 54 अपॉन प्लस 36. Krypton. Did I just get confused? Mass number Matthew, why do you make me 54, 36. This is their atomic number 36, 56. 36 and 56. 141 and 92. 92 to 35. 1 neutron, slow neutron. 56, 141. 36, 92. 3 slow neutron plus 200 mega electron volt, correct. Binding energy per nucleon is 200. Energy release upon 92 per nuclear. Mass number of 235 को convert this mother 235, that is 0.9 mega electron volt. The splitting of a heavy nucleus into 2 or more fragments of comparable masses with an enormous release of energy is called nuclear fission. When slow neutrons are bombarded at 92, 235, then fission takes place according to reaction. 235, 92, 141 plus 36, 92 plus slow neutron plus 200 mega electron volt. This three can collide with other 3 uranium nuclei, have huge amount of energy is released. Okay. Nuclear reactor, special इसमें कहीं moderator. H2 D2 युज गर्छौँ हैन, H2 नै युज गर्छ यहाँनिर इन्डियामा भारतमा. ले आफै
के
कुटी कुटी अब भोलि बजार गइदिन्छु ल.
जाने
ओइल ल्याइदिन्छु.
होस् न रे अहिले पैसा पनि छैन.
मेरोमा छ नि 700.
घरमा पसेर के कति सेभेन
नाक चिलाइ आफै मलाई
मार्गी लाग्नुलाई.
डस्टरको धुलोले जस्तो लाग्यो, चकको धुलोले है.
बिरामी नहोस्
दसैँमा किन बिमार हुनु? दसैँमा त स्ट्रङ हुनुपर्छ होइन, मिठो मिठो खानुको लागि. आफै हुँदैछ स्ट्रङ, मुख यसो सुकाउँदैछ, दाँत तिखार्दैछ.
के तिखा
अनि दसैँमा मिठो मिठो खानु परेन? आफूले तिखार्दैछ मैले देखेँ. किचनमा लगी लगी तिखार्दो रहेछ त्यो. यत्रो फाइल छ नि आमाको, दाँत तिखार्छ नि आफूले.
पैसा न कौडी
बजार बजार दौडी. ल भयो, डोन्ट डिस्टर्ब मी. गो गो गो. आमालाई डिस्टर्ब नगर्नु है ल. मोडरेटर, हेभी वाटर, heavy water. Graphite, Graphite, graphite. I can't believe they use graphite too. Moderator को काम किया to slow down the neutron. Slow down the neutron. Speed down the correction से तेरा slow down करना और वो in a fission reaction average fusion में combine हुन्छ या फिर separate हुन्छ. fission में separate हुन्छ क्या. Released extra neutrons can produce extra fission reaction and hence chain reaction. Controlled chain reaction can provide controlled reaction. reactive. Yeah. Slow neutrons are more likely to produce fission reaction than fast one. Okay. In an elastic collision, is rest maladin allowed. Elastic collision. In an elastic collision, you probably water, heavy water, D2 graphite to slow down the neutron, heavy neutron. Hmm. Hey, I am super irritated with that. In an elastic collision with hydrogen, neutron almost come to rest and proton always carry the energy. Critical condition. न्यूक्लियर रिएक्टर है ना, K is greater than 1, बॉम्ब बनने चाहिए था, खतरनाक हो खतरनाक. K is less than 1 और reaction end. Controlled drugs, cadmium, CD. The reason ले multiplication factor की बनेगी क्यों multiplication factor FACT हुआ multiplication factor की लगी बन सारी multiplication factor okay. The phenomenon of combination of two or more light nuclei to form a heavy nucleus with the release of enormous amount of energy is called the nuclear fusion. The phenomenon of combination of two or more light nuclei to form a heavy nucleus with release of enormous amount of energy is called nuclear fusion. The sum of masses before fusion must be greater than the sum of masses after fusion. The difference in mass appears a fusion energy. Okay, this is equal. The sum of masses. The difference in mass appears as fusion energy. The fusion of two deuterium nuclei into helium is expressed as 23.8 mega electron volt energy release under the. The fusion process occurs at extremely high temperature and high pressure. Isn't it? Just think. The fusion process occurs at extremely high temperature and high pressure, just as it takes place at Sun, where temperature is 10 to the power 7 Kelvin. Hence, fusion reaction are also called thermonuclear reaction. High pressure and high temperature. T is equals to 10 to the power 7 Kelvin. Temperature एकदम हाई, प्रेशर पनि के हुन्छ एकदमै हाई. THERMO thermonuclear reaction. RX and the reaction, thermonuclear reaction. Nuclear fusion has the possibility of being a much better source of energy than fission due to the following reaction. Okay, in fusion there is no radiation hazard as no radioactive material is used. Okay, no radiation hazard is the first point. greater energy efficiency पनि त राम्रो हुन्छ 23.8 mega electron volt release हुँदैछ. That means binding energy per nucleon will be higher than fission reaction. In fusion reaction, the fuel needed for fission, uranium 235 etc., is not available easily, whereas hydrogen needed for fusion can be obtained in fission. The fuel needed for fission, uranium, is not available easily, whereas hydrogen needed for fusion can be obtained in fission. What the heck? Fusion due to the following reaction. Thermonuclear reaction. Nuclear fusion has the possibility of being a much better source of energy than fission. Okay, this is correct. But what about this? Fusion can be obtained, whereas hydrogen needed for fusion can be obtained in. The energy released by nucleon is much more in comparison to fission. In fission. However, very high temperature and pressure required for fusion cannot be easily created and maintained, as it has not been possible as yet to use fusion for the power generation. Okay, fusion, we can't use it. 10 to the power 7 Kelvin. High temperature and pressure. Greater 23.8 mega electron volt. Okay, extremely high pressure for thermonuclear reaction. Another important point is that sum of mass of nucleons before fusion must be greater than the mass of nuclei after fusion. Before fusion must be greater than the sum of masses after fusion. Okay. Dual nature of. Okay, before going to dual nature, we have to revise something. It's okay. 1, 2, 3, 4. That's about completed henna. I guess so. Leave it. Atomic radii 0.52 into n square upon z. This is one. Another we have velocity is equals to 2.16 into 10 to the power 6 n upon z upon n. Z upon n. Kinetic energy is equals to minus of 13.6 into z square upon n square. Time is equals to 1.51 into 10 to the power minus 16 z square. I think it is n square. N square upon z cube. I don't know. I think it is z cube. I just forgot everything. 0.529. It's not 5 only. N square upon z. V equals to 2.16. It's 2.19. You mistake. N square upon, this will come in Armstrong. Velocity will be in meter per second. 2.19. It's 19. 2.19 into 10 to the power 6 Z upon N, correct, meter per second. Z square upon N square, this is for energy, this will be in electron volt. Z square upon N square, 1.51 into 10 to the power minus 6, I think this will be N cube upon Z, N cube upon Z second, this whole thing. N cube upon Z square. Lower minus NH orbit स्क्वेयर पनि हुँदो रहेछ हौ भगवान्, आर्मस्ट्रङमा हुन्छ ल यो सब. खानाको भन्नु न के दादाले कल गरेछ कि दुईपल्ट अनि यस्तै हेर्छु त 5 कि 4 बजे आइदिएर 5 बजे खुला 4 क्रस गरेको 4:30 5 बज्नु भएन हैन दुईपल्ट कल गरेछ अनि मेसेज गर्छ मैले भने किन खाना दादाले छक्क गरेछ यस्तो ठुलो क्वेशनमा
रातभरि सुत्ती छैन अघि राति
अन्त म अस्तिको राति र अस्तिको दिउँसो होली किन रातभरि सुत्दिनँ होइन हिजो बेलुका त म बेसी सुतेन नि 5 बजी सुतेँ होइन 5 बजीदेखि 6 बजी खबर थियो होला आमा आइपुगेको थियो 6 बजीदेखि 9 बजीसम्म सुतेँ त्यहाँदेखि त उठिहालेँ त त्यहाँदेखि त 2 बजी कि 3 बजीसम्म त बेलुका बसिरहेको थिएँ साढे कि कतिसम्म पढेको थिएँ 3 बजी सुतेँ होला त्यहाँदेखि 3 बजी सुतेर हजुर मलाई लाग्छ दिउँसोमा म ढिलो उठेँ भने 1 बजीतिर उठ्छु भने अस्ति त त्यसको बेलुका पनि सुत्नु दिउँसोमा सुत्नु मन पर्थ्यो तर हिजो बेलुका मलाई 3 बजी सुतेको आज दिउँसो 2 बजीतिर उठ्छु लास्ट भनेको 1 बजी हो हिजो उठेको तर आज चाहिँ 1 बजी र 2 बजी आफूले त्यसो डाइरेक्ट 5 बजी मलाई त भोलि हेर्दा कति आउँछ है काम छ है अनि त अब छोडिदिनु h/2 pi integral multiple of h/2 pi angular momentum okay. This is centripetal force mv square by r mv square by r 1 by 4 pi epsilon naught q1 q2 by r square let's say upon del E 12,400 upon del E and electron volt nanometer is equals to h nu है ना हाईएस्ट कति बेला हुन्छ भन्नु त मेन इलेक्ट्रोन ट्रान्जिसन from higher to lower orbit the transition from higher to lower orbit that is n equals to 1 lower orbit n equals to 1 E nth electron in nth state n equals to number of different wavelength spectral line different spectral line n minus 1 upon 2 हो इसको तो n orbit number हो the change in energy is equals to h nu times 1 into frequency energy of photon del E is equals to ei minus ef emission spectrum matter and magnetism lambda is equals to h upon p energy total is equals to minus of kinetic energy equals to minus of binding energy or ionization energy, which is equals to potential energy upon 2. N equals to 1, n equals to 2, n equals to 3, 4, n equals to 5, n equals to 6. Okay, 1 हुँदाखेरि एनर्जी कति हुन्छ भन्दा माइनस अफ 13.6 इलेक्ट्रोन भोल्ट E1, E2 कति हुन्छ माइनस अफ 3. I think 14. I don't think so. Is it 14? 3.4 electron volt. 3.4 minus of 3.4 electron volt हुन्छ. Second मा यसको हुन्छ 1.51 electron volt को भी negative. The 0.51 electron volt minus of 0.34. No, you 85. This is 54 electron volt. Okay, I almost forgot everything. Minus of 3.4 electron volt person. 85 right? 54. 3 E4 0.85 negative of 0.85 है ना. E5 is equals to minus of 0.51 electron volt. 54 minus of 0.85 E6 मा E5 मा 54 electron volt no. P formula. First. Last line in series limit मा कति हुन्छ इन्फाइनाइट हुन्छ. This is super important. लम्डा मिनिमम फोटोन को वेवलेंथ मिनिमम हुन्छ तर के हुन्छ फ्रिक्वेन्सी मैक्सिमम हुन्छ इमिटेड डेल ई मैक्स. फोटोन एमिट गर्दा के हुन्छ फोटोन को वेवलेंथ चाहिँ मैक्सिमम हुँदैन वेवलेंथ मिनिमम हुन्छ फ्रिक्वेन्सी मैक्सिमम हुन्छ नि त. cot 30 degree root 3 cot 45 degree 1 cot 60 degree 1 by root 3. Stopping potential. EV is equals to stopping potential के हुन्छ भन्दा त del E minus H phi हुन्छ del E minus phi which is equals to H nu naught minus phi लेख्दा पनि भयो. cot 30 degree कति हुन्छ cot 60 degree का तीन सौ cot 45 degree तो 1 1 under root 3 30 degree में 60 degree में 1 upon root 3 am I right? Correct. Cot 30 degree root 3 cot 45 degree 1 cot 45 degree 1 cot 60 degree cot 60 degree is equals to 1 upon root 3 cot 30 degree root 3 cot 45 degree 1. Okay, impact parameter B ले represent करता हूँ. B equals to 0, theta is equals to 180 degree. Impact parameter direction, so the distance between nucleus. Cot theta upon 2. Theta by 2. It decreases. Radius increases. Radius increases. Yeah. So this is it. Atomic number decreases. Inversely directly proportional to cot theta upon 2. Yeah. Distance of closest approach to Z E square 2k Z square upon kinetic energy. Okay. B impact parameter is equals to k Z E square upon kinetic energy. Okay. Cot theta upon 2. Thomson atomic model, lump burning model, charge to mass ratio, electron for atomic structure found, Rutherford model of the atom, discovery of nucleus, Gold foil experiment, bombarded alpha particle, electron revolve around the nucleus, atoms are mostly empty space, 1 in 8,000 alpha particle will deflected more than 90 degree. 1 in 8k alpha particle were deflected more than 90 degree. Small and positively charged dense center called nucleus. Size of nucleus 10 to the power minus 15 15 meter. Size of atom 10 to the power minus 10 meter. Theta, angle between direction of alpha particle. Deflection. Thickness of gold foil 2.1 into 10 to the power minus 7 meter. Alpha particle 5.5 mega electron volt energy test. Okay, energy of alpha particle 5.5 mega electron volt. Gold foil 2.1 into 10 to the power minus 7 meter. Centimeter. Right. Hey, I just don't know about it. Centimeter. 100, right? 10 to the power 2. That means wait a minute. Distance of closest approach. Only 0.14% deflected by more than 1 degree. Deflected by. Distance of closest approach. I just don't know anything. Okay, so we have a distance of closest approach. Ma alpha particle हुन्छ जसमा प्लस 2e हुन्छ चार्ज अफ अल्फा पार्टिकल. यसमा के हुन्छ अल्फा पार्टिकल हुन्छ जसमा दुईटा इलेक्ट्रोन निकालिसकेपछि के हुन्छ भने त प्लस 2 e हुन्छ यहाँनिर. दुईटा प्रोटोन दुईटा न्यूट्रॉन हुन्छ. दुईटा इलेक्ट्रोन निकालिसकेको त्यसमा के we bombard this alpha particle in the nucleus. This is nucleus. Nucleus को चार्ज कति हुन्छ z. एटोमिक नंबर जति हो प्लस न्यूक्लियस को चार्ज e मान्यो भने हामीले कति हुन्छ के यसको न्यूक्लियस को चार्ज कति e मानेको छ हो k2 यस्तो दुईटा इलेक्ट्रोन निकालिसकेको छ. z e भनेको छैन अल्फा पार्टिकललाई बम्बार्ड गर्दैछ. एउटा यस्तो पोइन्ट हुन्छ जहाँनिर चाहिँ पुग्नु भन्दाखेरि अगाडि नै के हुन्छ दिस इज डी डिस्टेन्स अफ क्लोजेस्ट अप्रोच. एउटा यस्तो पोइन्ट हुन्छ जसमा चाहिँ न्यूक्लियसमा बम्बार्ड हुनुभन्दा अगाडि नै के हुन्छ पोजिटिभ रिपेल पोजिटिभ दे बोथ के हुन्छ रिपेल सेम चार्ज लाइक रिपेल हो नि त. यहाँ भएर के हुन्छ रिपेल हुन्छ न्युट्रोन मरेर डिफ्लेक्ट हुन्छ. इनिशियल काइनेटिक एनर्जी रेस्टमा आउँछ, पोटेन्शियल एनर्जी रेस्टमा आउँछ. ओके, फर्स्टमा इनिसियल कति छ, काइनेटिक एनर्जी छ, रेस्टमा यो एउटा पोइन्टमा आएर त्यहाँदेखि के हुन्छ, डिफ्लेक्ट ब्याक हुन्छ. पोटेन्शियल एनर्जी W इक्वल्स टु perpendicular distance between direction of alpha particle and the center of nuclei. Perpendicular distance between direction of alpha particle. Direction of alpha particle and just calm down, okay? You can do it. Just calm down. Don't think about it. Shh. Direction of alpha particle to the nucleus. Perpendicular distance between alpha particle, direction of alpha particle and center of the nucleus. Okay. Center of the nucleus, correct? You basically lied. Sadia. Theta, angle between direction of alpha particle and their deflection. Theta, angle between the direction of alpha particle and their deflection. Okay. B equals to 0, then theta will be 180 degree. Parameter, impact parameter 0.70 हुन्छ, theta 180 degree हुन्छ. For larger value of B, theta is equals to 0. Oh. Impact parameter, okay. Theta equals to 180 degree. Theta deflect भएर 180 degree भयो भने के हुन्छ भने त impact parameter 0 हुनुपर्छ. जब बीटा impact parameter increase हुन्छ, theta के हुन्छ decrease हुनुपर्छ. जब theta को value 0 degree हुन्छ, theta deflection 0, then B impact parameter को value के हुन्छ increase हुन्छ. The large value of B, theta is equals to D. Beta increase हुन्छ. Yep. I just didn't get it. Z E square cot theta by 2. Question. In hydrogen spectrum, the shortest wavelength in Balmer series is lambda. Shortest wavelength. Wavelength. Series limit. Shortest wavelength, last line. Series limit. Shortest wavelength of in hydrogen spectrum, the shortest wavelength of Balmer series. Zero इसको कति लिख सकते हैं value lambda छ रे हो. The shortest wavelength in bracket series is bracket Lyman Balmer Paschen bracket Lyman Balmer Paschen bracket n equals to 4 lower na 4 को square minus 1 upon this whole term will be 0. Then is it? I don't think so. Hey, Lyman Balmer Paschen, yep. And then bracket 1 2 3 4 it is. You are correct. 4 4. That is 4 4 16. The shortest wavelength in bracket series is I think I did something wrong. Oh ho. R का value कौन लिखेगा रे? One of this whole thing. Here we have to put R. So 16 upon R. From here, lambda is equals to 16 upon R. Okay. यहाँ पर क्या होगा 1 upon lambda is equals to 1 upon 4. पर भी तो R होता है. तो ये तो सिंपली हो गया ना यहाँ पर एक R हो गया R. तो lambda is equals to 4 by R. If we calculate the value of R from here, 4 upon lambda. Equation 1. R को value का 4 upon lambda देखो. So here, from here we can write 16 upon 4 multiplied by lambda. So what's 4 was 16, right? 4 lambda. 4 lambda, right? Yup, you are correct. You are correct. If an electron in a hydrogen atom jumps from third orbit to second orbit, electron in H atom jumps from third orbit to second orbit, it emits a photon of wavelength lambda. When it jumps from fourth orbit to third orbit, the corresponding wavelength of the photon will be from fourth orbit to third orbit. Okay, emission spectrum. Emission Spectral. Oh my goodness. Light reflection and refraction. Oh. Shut up, bro. Shut up. Reflection of light, spherical mirror. Image formation by spherical mirror. Refraction of light. Or refractive index. Spherical lenses. You don't have any choice, you have to study hard. Okay. First it is n equals to 3 to n equals to 2. Just n equals to 3 to n equals to 2. R 1 upon 3 lower orbit बनेगा तो ये higher orbit लिखती हूँ 2 to 1 upon 3 को square. This will probably be 1 upon lambda is equals to R 1 upon 4 minus 1 upon 9. 4 9s are 9 9 36. 4 ka 3 is 36. 4 9s are 36 minus 9 4 is 36. Lambda equals to, here don't forget to write R Ima please, 36 upon 5R. If you calculate the value of R from here, it will be like 36 upon 5 lambda. Equation 1, okay. Then we have n equals to 4 to n equals to 3. It's given here. 1 upon lambda is equals to R 1 upon 3 को square minus 1 upon 4 को square, which will be approximately R 1 upon 9 minus 1 upon 16. Lambda is equals to 16 into 9. It will be approximately 16 into 9, that means 9 first of all 9 6 54 को 4 5 इतना गया 9 10 14 144 9 16 is 144 16 9 is 144 R, which will be like 16 minus 9 10 7R upon 144. Therefore from here lambda is equals to 144 upon 7R. From here the value of R is, equation 1, it is 144 upon 7 into 36 36 upon 5 lambda, that means multiplied by 5 lambda. So if we divide this by 2, 2 7s are 14, 2 2s are 4, 72, 2 1s are 2, plus 1s 2 8s are 16, right? 18 upon 72. Again it is 2 3s are 6, 2 4s are 12, 2 9s are 18, 34. I'm for you. I'm for you. A 34 into 5 lambda upon 7 into 9. Is it 9? 2 9 18. Yup, it is 9. 3 10 3 33. So 3 के टेबल में तो नहीं आएगा. 7 के टेबल में आता है. 7 1 7 7 7 7 7 plus 28 7 plus 35. Nope. 5 4s are 20 equals 0. 2 तक गया. 5 1 5 is 10. 5 3 is 15. I don't think इतना बड़ा नंबर आएगा. 7 7 7 7 9 63. 63 lambda. तो क्या एरर होगा इसमें. 144 upon 7r, right? The value of r is 36 upon 5 lambda. 144 upon 7 into 36 upon 5 lambda. So here 7 1s are 7, 7 2s are 14, 7 3s are 21. 2 2s are 4, 2 7s are 14, 2 2s are 4, 72 correct. 2 1s are 2, 2 8s are 16 correct. 2 3s are 6, 2 4s are 12 correct. 2 9s 18. Again this is the same thing. 34 into 5 upon 9 lambda. What kind of error I am making? 2 6 are 12, bro. This is 2 6 are 12. You made the same mistake again and again. 2 3s are 6, 2 6 are 12, not 2 4s are 12. It's 2 6. 36. 9 1s are 9, 9 2s are 18. So from here, 9 1s are 9, 9 1s are 9, 9 18, 9 4s are 36. 4 into 5, that is 20 upon lambda. 7 lambda. 20 upon 7 lambda. This is the answer. Just do it, bro. Just do it. Let T1 and T2 be the energy of electron. T1 and T2 is energy, not. They are energy, not time, okay? So the formula for energy is equals to minus 13.6 Z square upon N square excited. First excited means N equals to 2 ma energy. First N, second excited states. First Madhuyamsa, one is second excited state. 2 plus 1, that is 3. T2. According to the Bohr model of an atom, the ratio of T1 upon T2. Okay, this one is for 2, this one is for 1. For energy we have T1 upon T2, right? Ratio of, according to the Bohr model of an atom, the ratio of T1 and T2 is equals to minus of 13.6 Z1 square. For both it is hydrogen, right? Upon N1 square. That is 2 here. Then again minus of 13.6. We have Z, same, okay, Z2 square upon N2 co square. Minus minus cancel. 13.6 cancel. If this is hydrogen atom, H Z equals to 1. For both it is 1 1, so this will be cancelled. The only thing that remains is N2 co square upon N1 co square. It is given that N1 is equals to T1 upon T2. N1 भनेको कति दिएको छ 2 दिएको छ 2 2 4 हो. And for n2 कति दिएको छ 3 3 को स्क्वायर 3 3 is 9 9 upon 4 the ratio of T1 to T2 यसको रेशियो कति हुन्छ त 9:4 The total energy of an electron in nth stationary orbit of the hydrogen atom can be obtained by total energy in nth state. We have this formula, right? Energy in nth state is equals to energy in ground state plus energy given. VEN given. Okay, the total energy of an electron in nth stationary orbit of the hydrogen atom can be obtained. This is basic. E equals to minus 13 point. Okay, the total energy of electron in nth stationary orbit of the hydrogen atom can be obtained by, this is basically minus 13.6. We have z square upon n square electron volt, and for hydrogen atom z equals to 1. So this is basically electron is equal to minus 13.6. 1 को square 1 है upon n square in electron volt. 1 को square will be 1. So the answer is minus 13.6 of an electron in second orbit of sodium atom. The velocity of electron in second orbit of sodium atom, n equals to 2. Okay, x equals to the velocity of electron in second orbit of sodium, x kunjesa n है sodium atom, z equals to 11 is v. The velocity of electron in fifth orbit will be we have the velocity formula. A equals to 2.19 into 10 to the power 6, that is z upon n, isn't it? Yep, it is. So they are asking us the velocity of electron in fifth orbit. They're inversely proportional, okay? Velocity and the velocity of an electron in second orbit of sodium is v. Velocity of sodium atom is equals to n2 upon n1. So v1, velocity of an electron in second orbit, n1 कति बनेको छ 2 बनेको छ will be the velocity of electron in fifth orbit will be v2. Okay, so from here we can write that v2 equals to v1 2 times v1 upon 5, or v2 is equals to 2 times v upon 5. 2 times v upon 5, correct. This one, I have to solve this one. I just want to solve this one, okay? Yep, you have to solve this one. I'm just irritated. You don't have to. You have to complete this, whatever. You have to complete this. Hydrogen atom in ground state is excited by a monochromatic radiation. Monocolor. Same wavelength, right? Yep, I guess so. Hydrogen atom in ground state is excited by monochromatic radiation of lambda equals to 975 Armstrong. Number of spectral lines in the resulting spectrum emitted will be hydrogen atom in ground state is excited by a monochromatic radiation of lambda equals to 975 Armstrong. Number of spectral line in the resulting spectrum will be. Okay, they are basically asking us the value of n, total number of spectral lines, which is given by n minus 1 upon 2. Hey, just shut up. No, I'm just irritated, okay? You don't have to. Hydrogen atom in ground state is excited by a monochromatic radiation of lambda 80 degrees. Okay, so energy in nth state. It is not even asked in the question. How will you know? I just don't know. You have to just practice. Hydrogen atom in the ground state is excited by a monochromatic radiation of lambda 80. Number of spectral lines in the energy in ground state minus, no, it is plus energy given, isn't it? Yes, so energy in ground state plus energy given. Ground state minus of 13.6 electron volt plus how much energy is given. We are not aware of it. We have to calculate this one. Where will you calculate? Just do it here. Energy given. H nu, right? If energy is H nu. Initial and final. I'm not just aware. Okay, we have to calculate wavelength. But for what? I don't know. Energy given. Hc upon lambda. 12,400 upon 975 Armstrong. That will be like 5 ones of 5, 5 nines of 45, and then again 2. 5 5s are 25. Then we have 5 2s are 10, 5 4s are 20, 5 8s are 40, and 0. Again, 5 3s are 15, 16, 17, 18, 19, 4, 5 9s are 45, 5 4s are 20, 5 9s are 45 again, and then 46, 47, 48, 3. 5 15, 30, 5 6 are 30. This will go like EG is equals to 496 upon 39. Is it? 3 ones are 3, 3 3s are 9, right? But here 3 ones are 3 and 3 6 are 8. No, this is not divisible by 3. I don't know, maybe this is divisible by 39. I just don't know. Okay, I don't think so. 5 means 16, 15, 16, 17, 18, 19, 195. Just divide it here. 496, 39, 139. And it will be like 106. 39 into 3. 3 3s are 3 9 9 9 7 7 2 8 5 3 3 9 10 11 117. So this is 12 point something. Minus 13.6 electron volt plus 12 point how much, I don't know. 39 into 2, 2 9s are 18, 3 2s are 6 7, 78. This will basically be 8, and then we have 9 upon 9 minus 7, right? Then we have 2, 280. That means it will be bigger than 5. Okay, 280. That means around 7. 39 into 7. 7 7 is 14. 7 is 56. 7 9 is 63. 3. 7 7 7 is 14. 7 3 is 21. 21. 22 23 24 25 26 27. 27. 273. Correct. 12.6. I don't want to calculate more. 12.6 electron volt. So from here, your energy will become minus of 1.0. Really? Ha ha ha. ऐसा वाला तो कोई और भी ही नहीं, which is approximately n equals to 4. 0.85 के पास तो वही है ना. हाँ, इससे 1.51 का. So from here, n equals to 4. 4 minus 1 upon 2. You can't calculate this in exam, I guess. 4 4 is 16 minus 4 1 is 4 upon 2. This will be like n equals to 12 upon 2. That is 2 is 2, 2 3 is 6. N equals to 3 upon 1. That is 3. A 2 6 is a 12, not 2 3 is a 12. Why are you making such a silly mistake? Okay, just shut up. Shut up. Focus here. This is messy. Why can't you just solve it? I don't know. I just can't solve it. Why? I also don't know why I can't solve this simple thing. Electron in that atom comes from excited state n equals to 3. .1 electron. 5 is given already. Oh, this is messy. Super messy. I just can't solve anything, but I have to. I just don't know anything about the NEET chapter. I basically forgot everything. 75. How can someone be so dumb? It's okay, you can do it. You have to do it. You don't have any other option. A You don't have any extra copy or what? You can use this one. Yep, I can use this one. Let me bring some water. Water for next session. For next session, I have to drink water. Hey, you can't, I think. But I can. I have to. You can't. Which one of the following Bohr model is not valid? Neon, obviously. The total energy of electron in another stationary orbit of a hydrogen atom can be obtained by Z square upon hydrogen atom. Okay, Z is not given. N square. This is again 3. Let's write this one, okay? The radius of the first permitted Bohr orbit for the electron in a hydrogen atom is equals to 0.51 Armstrong. Radius is given in Armstrong. Here it is R equals to 0.529 into N square upon Z Armstrong. If I'm not wrong, this is the 0.529 into N square upon Z Armstrong, correct? The radius of the first permitted Bohr orbit for the electron in a hydrogen atom equals to, so this is basically R1, right? Equals to 0.51 Armstrong. First permitted Bohr orbit for the electron. Hydrogen atom is 0.51 Armstrong. 0.51 is not given, but if it is 54, 0.54, then this is basically approximately n equals to 4 hoga. And its ground state energy equals in ground state energy, okay, energy in ground state is equals to minus 13.6 electron volt, correct? If the electron in the hydrogen atom is replaced by muon, mu minus, charge same as electron, okay, that is -1, and mass 207. The first Bohr radius and ground state energy will be, wait, they are asking us ground state energy for muon, right? And the radius for muon. Okay, so do we have to calculate? Muon R equals to 0.529 into N square upon Z, right? N is number of orbit. Z is equals to mass number or atomic number. The energy will be same, I guess. Energy is equals to minus 13.6 Z square upon N square. Mass number. Z plus number of neutron. We don't know what is Z in this case. 207. Do we know 207 is equals to Z plus N? atoms. Previous question 3 को 4. In 2019. Okay. The total energy of an electron in an atom in an orbit is, I'll just total. Okay. To here. Okay. This is n equals to 2. N equals to 2, right? Yep, you're right. Ciao. Its kinetic and potential energy are respectively. Its kinetic energy and potential energies are respectively kinetic energy plus 3.4 and potential energy is equals to 2 4 is 8, 2 3 is 6.8. Both are in electron volt. That is minus of 6.8. 4 को 3. 4 को 3. The ratio of kinetic energy to the total energy of an electron in a Bohr hydrogen 1:1, but total energy will be negative. 1:-1. That is 2. For 5 it is 2. The ratio of wavelength of the last line of Balmer series and the last line of Lyman series is, okay, for Balmer and Lyman last line, right? That for Lyman it will be like, the ratio of wavelength. Okay, wavelength. Lambda is equals to a 4, right? 2 to the 4. Lyman को तो 1 हुन्छ नि त. 1 को square 1. 1 upon r. For Balmer it is last line infinity 0. Balmer 1 upon 2. 2 को square 2 to the 4 obviously 4 1 upon 4 4 upon r 4 upon r lambda Lyman upon lambda Balmer, right? 4 1 upon Lyman 1 upon r 1 upon r Balmer 1 is 4 upon this is r cancel 1 is to 4 1 is to 4 sheet the ratio of wavelength of last line of Balmer to Balmer so first one line in Balmer to Lyman and the last line of Lyman series okay Balmer को last line कति आई बना था for this is for Balmer right yep this is for Balmer 4 upon r and for Lyman it is 1 upon r so r cancel 4 is to 1 which is also known as 4 हाँ 6 को 3 till here then I have to calculate for here 7 if an electron in a hydrogen atom jumps from third orbit to second orbit n equals to 3 to n equals to 2 it emits a photon of wavelength lambda when it jumps from fourth orbit to third orbit photon की होता wavelength lambda सा n equals to 4 to n equals to 2 माझा this okay the corresponding wavelength of the photon will be okay from here I have to calculate the value of r okay 1 upon lambda is equals to r upon 2 co square minus r upon 3 co square which is probably 4 here 9 4 9 is 36 4 kati is 36 4 9 is 36 9 4 is 36 r this is basically lambda is equals to you 1 upon lambda ho 1 upon lambda 5r upon 36 lambda is equals to 36 upon 5r but I have to calculate the value of r right r equals to 36 upon 5 lambda this is equation number 1 then the other I have to calculate n square 2 plus 2 whatever n equals to 2 n equals to 4 to n equals to 2 now this one basically 1 upon lambda is equals to 1 upon 2 co square minus 1 upon 4 co square whole times r this will become r times 1 upon 4 minus 1 upon 16 that is 2 to the 4 4 to the 16 right yep then this is again equals to 4 6 4 is 24 6 is 24 को 4 2 तो गए ना 4 4 5 6 I haven't seen anything like that. Ooh. If an electron in a hydrogen atom jumps from third to 2 orbit it emits a photon of lambda. When it jumps from fourth orbit to third orbit it's not 2 this is 3 be careful 3 is a 9 9 into 16 that is 144 6 9 16 minus 9 okay this is multiplied by r which is equals to 1 upon lambda is equals to r times 7 144 1 times lambda is equals to r again flip it lambda is equals to 144 upon 7 times r okay from here 1 I have just calculated this 7 into 36 upon 5 lambda 2 9s are 18, 2 3s are 6, 2 6 are 12, and 9 and 3 9 4s are 36. Lambda is equals to 4 5s are 20 lambda upon 7. 20 upon 7 lambda. Okay, this is 3. 7 को 3. मेरो फोनको चार्ज सकिन आँट्यो कि सो आई हेभ टु चेन्ज माई पोजिसन ब्रो. अघि खाएँ आम पहिला फेरि भोक लागेको. चेन्ज पोजिसन. Of sound, propagation of sound, sounds medium to travel. Seven को 3. Did I wrote it? 7, 8. When an alpha particle of mass m moving with a velocity v bombards on a heavy nucleus, charge Z, its distance of closest object from the nucleus depends on mass h, as not h. Okay, there is alpha particle plus 2e, charge and proton. Here we have nucleus. It is Z. This is the distance of closest approach. D is equals to K 2E Q1 Q2 ZE upon kinetic energy, which is equals to 2 times mass पे बोला है, mass पे 2 times KZE upon kinetic energy, mv square. E क्या है? मास और चार्ज है, चार्ज. Alpha particle of m, mass m, moving with the velocity v. Kinetic energy बनेगी क्या होना था? हाफ एम वी स्क्वायर. half mv square, right? So this will be like 4 times kze square upon mv square. So d से तो ये तो इन्वर्सली प्रोपोर्शनल हो गया यहाँ से m 2. Given the value of Rydberg constant is 10 to the power 7 meter inverse, the wave number of the last line of Balmer series wave number 1 upon lambda 1 10 to the power 7 1 upon last line बनेगा. See 1 upon 2 square यानी the whole times 0 answer, which will be like, this will be like 10 to the power 7 upon 1 upon 4 है ना. 10 to the power 7 upon 4, which is equals to r upon 4. If I further expand it, then it will be like here 10 to the power 6. Okay, 4 1s are 4, 4 2s are 8. Point 2 7 4 5s are 20. This is 1 upon lambda. Wave number is equals to 2.5 10 to the power 6. 2.5 into 10 to the power 6. using thermal rate of helium using non-relativistic approach. The speed of electron non-relativistic approach. The speed of electron in the orbit will be given. Consider third orbit of helium using non-relativistic approach. N equals to 3. The speed of electron in this orbit will be V equals to 2.19 into 10 to the power 6, that is Z upon N. 2.19 into 10 to the power 6 Z कति हो, helium को 2 हो, N कति देखो छ 3 देखो छ. So this will be like V equals to 2 9 18 को 8, 2 1 2, 3, 2 2 4. 3 1 3, 3 1 3.36, 3 4 12, 3 4 12, 3 7 3 6 18. This is basically 1.46 into 10 to the power 6 meter per second. 1.46 into 10 to the power 6 meter per second. That is option number 3. Three correct. 2 को 3, 3 को 4, 4 को 3, 5 को 2, 6 को 3, 7 को 3, 8 को 2, 4 and 3. Correct. Hydrogen atom in a ground state is excited by a monochromatic. Same question. Spectral line in the resulting spectrum emitted will be. So, number of spectral line in the resulting spectrum will be. I have just done this, right? Energy. ratio of longest wavelength corresponding to Lyman and Balmer series. Lyman to Balmer is the ratio છે. Lyman wavelength Lyman and Balmer. Okay. First Balmer को calculate करता फिर हम. First right longest wavelength means okay. 1 upon 1 को square minus 1 upon 2 को square. तीन से बना था 1 4 4 1 का 3 4 4 minus 2 का 4 1 से 4 equals to 3 upon 4 1 upon lambda. Lambda is equals to summa r पनि हुन्छ ल 4 upon 3r. Now I have to calculate for Balmer. For 9 से 36 9 minus 9 4 से 36 times r equals to 5r upon 36. Lambda is equals to 36 upon 5r. This is for Balmer. So the ratio Lyman to Balmer 4 by 3r. Balmer को what is 36 5r 4 1s are 4 4 9s are 36. Okay, so this will be 5r upon 27 27r 5 upon 27 5 is to 27 4 Electron in a hydrogen atom first jumps from third excited state to second excited state, and then from electron in the hydrogen atom jumps from the third excited state to second excited state. N equals to 3 to n equals to 2. Second excited state to first excited. 1. The ratio of wavelength lambda 1 upon lambda 2 emitted in two cases is lambda 1 to को ratio को तुम लिख सकते 1 upon lambda 1 is equals to r times 1 upon 4 minus 3 3 is 9. This will be like 4 9 is 36 minus 4 times r 1 upon lambda 1 is equals to 36 5 r. Okay, so from here lambda 1 is equals to 36 upon 5 r. From lambda 2 to 100 upon lambda is equals to 1 upon lambda 2. What is the lambda 2 is 1 upon 4 r. When lambda is equals to 4. Is it? Yup, it is. Just shut up. Upon 4r. So from here lambda is equals to 4 times 3r. 4 times 3r. Say r. Okay. 4 ones are 4. 4 nines are 36. 9 into 3 upon a. This is again same. 5. 27 upon 5. The velocity that the atom acquired as a result of photon emission will be. The velocity that the atom acquired as a result of photon emission भनेपछि p यहाँनिर हुन्छ हैन माइनस v हो यसको मास कति छ m थियो अरे ओके रिकोइल भयो नि हामीलाई के दिएको छैन त pi is equal to pf एक्सटर्नल फोर्स छेउ एक्सटर्नल फोर्स 0 छ भने के हुन्छ इनिशियल मोमेन्टम र फाइनल मोमेन्टम बराबर Pf is equals to P minus mv. Okay, 0 P minus mv mass into velocity. हामीलाई के चाहिँ खोज्नु भनेको छ है त्यसको भेलोसिटी खोज्नु भनेको छ के भनेर मास इन्टु भेलोसिटी h upon lambda. V equals to h upon lambda m. So we have to calculate wavelength, right? Yep, we do have to. An electron of a stationary hydrogen atom passes from fifth energy n equals to 5 to n equals to 1. Okay. 1 upon 1 को square r times minus 1 upon 25, which will be like 25 minus 1, 24 r. So this will basically be lambda is equals to 25 upon 24 V equals to h upon 25 mass 25 r mv square. So why there is no V equals to 25 hr upon 25 m. 25 hr upon 25 m. 3. The transition from the state n equals to 3 to n equals to 1 in a hydrogen atom results in ultraviolet radiation. Infrared radiation will be obtained in the transition from the transition from a state n equals to 3 to n equals to 1. 3 देखिए 1 नाउँदाखेरि कुन चाहिँ पायो अरे result into ultraviolet radiation. लाइमन लेखिदिन्छ UV ultraviolet. बाल्मरले visible. Lyman Balmer. Passion bracket and P fund. सबैजना लेखिदिन्छ IR. Three to n equals to 1. Equals to 3, n equals to 4, n equals to 5. Lyman, Balmer, this is IR 4 to 3 up. कुछ सीरीज वाला था 4 देखिए 3 में this one. Passion. The wavelength of first line of Lyman series for hydrogen atom is equal to the second line of Palmer series. What the heck is this? Who's fine? The wavelength of first line of Lyman series for hydrogen atom. An electron in the hydrogen atom jumps from excited state into the ground state. The wavelength so emitted eliminates a photosensitive material having work function 2.75 electron volt with a stopping potential 10 volt. Then the value of N is I also don't know. The wavelength of, okay, first EV stopping is equals to h nu, energy into work function. EV stopping equals to energy h nu, h nu or hc upon lambda upon multiplied by 5, okay. An electron in the hydrogen atom jumps from excited state and n to ground state. The wavelength so emitted illuminates a photosensitive material of work function phi equals to 2.75 electron volt. If the stopping potential of the photoelectron is 10 volt, wave stopping equals to 10 volt, then the value of n is, okay, let's see upon lambda. And why they asking us the value of n? This is energy. Wavelength of hydrogen atom jumps from excited state and to ground state. We don't know how much energy is given, right? Because wavelength is not mentioned. Work function is given. The stopping potential is also given. So from here we can calculate, I guess. एनर्जी कितना आएगा उससे देख के तो हम लोग कर ही सकते हैं ना. E stopping upon 5, so this is 10 volt. .75 इलेक्ट्रॉन वोल्ट कट गया ये, तो बेसिकली ये बचेगा 10 अपॉन 2.75. 2 1s are 2, 2 3s are 6. This is 2 7s are 14, 2 5s are 10, 2 5s are 10. Can we just do that? Five into 10 to the power 3 upon 1375. 1 2 3, that is 5,000. 5,000 upon 1375. 1375. We just cut it with, okay, 1375. 5 ones are 5. 5 2s are 10. 5 is 1, 35 cents are 35. 5 5s are 25. 5s are 25. 5 2s are 10. 5 1s are 5. 5s are 5. 5 4s are 20. 0 0. 40 divided by 11. 11 3s are 33. Stopping potential. Stopping potential is always negative. ये तो dual nature का question है. यहाँ कैसे है? Dual nature. Seven 0. 11 6. This is 66, 4, 0. 11 4 is 40, 11 3 is 33. 33, okay, leave it. 3.63 minus 3.63 मीन्स n equals to 2. तो ये तो n equals to 2 हो गया. 16 17 को 2. V stopping rate, V stopping potential हमेशा नेगेटिव होता है. वो फंक्शन का नहीं पता, लेकिन ये तो नेगेटिव ही रहेगा. तो -3, हाँ, n equals to 2, सही. Out of the following, which one is not a possible energy for a photon to be emitted by a hydrogen atom according to our atomic model? Out of the following, 13.6 electron volt, 1.9 electron volt, 11.1 electron volt, and 0.65 electron volt. Out of the following, which one is not a possible energy by a photon to be emitted by a hydrogen atom according to our atomic model? One is not a possible energy of a photon to be emitted by a hydrogen atom according to our atomic model. One point 13.6, 3.4, 1.51, 0.85. The energy of a hydrogen atom in the ground state is -13.6. First excited state. One point 13.06 z square 2 को square upon 2 को square. The distance of closest approach. This is half mv square. This is 2 times k. Z 4kZe²। देखो इसमें क्या होगा कि एक चार्ज होगा हमारा 2e, दूसरा होगा Ze, तो इसमें से होगा 2Ze² ना, तो 2 मल्टीप्लाई होकर 4 गया kZ², और mv², तो d किसके प्रोपोर्शनल होगा, Z और e के, mv² नीचे आएगा, e² Z और e के स्क्वायर के प्रोपोर्शनल, ये तो गलत है, mv², राइट, mv² से इन्वर्सली प्रोपोर्शनल होगा, m से भी इन्वर्सली, v² से भी, तो 20 का होगा 3। थ्री फोर टू थ्री 4 15 देखिए, 4 1 4 4 1 4 4 1 4 1 4, okay, again another mistake, 19 को 2 3 2 3, सेवेंटीन, 4 13 2 An electron of hydrogen atom first jumps from third excited state to second excited state. Third excited state to second excited state, that is 4 and 3, right? 4 and 3. ये तो गलत हो गया है ना, यहाँ पर 9 होना था, यहाँ पर 3 होना था। Electron in hydrogen atom first jumps from third excited state to second excited state. You just did it incorrectly. One upon lambda 1 is equals to 3 3 is 9, 4 4 is 16 minus should we have r here also r. This will be like r 144 16 minus 9. Lambda 1 is equals to 144 upon 7r. And there 6 7r, right? How much did I get from this bullshit? 27 by 5. I got 27 by 5. Huh. What the heck? A 9 and 16. 36. 3 and 2. Did I wrong? Oh my goodness, this is. I didn't put plus 1. Hydrogen atom. Hey. Just from third excited state to second excited state, and then from second excited state to first excited state. Oh, so I just did a messy thing over here, and then jumps from an electron in hydrogen atom. First jumps from third excited state, that is 4, to second excited state, that is 3. Then from second excited state to first. Second excited state means 3, right? To first excited state, 2. R, which is equals to R upon 2 to the 4, 3 to the 9. 9 is 36. Which is equals to 5R, right? Yes, it is 5R upon 36. Lambda is equals to 36 upon 5R. The ratio of wavelength lambda 1 is 144 upon 7R. Lambda 2 is 36 5R. Didn't I just got this while taking the ratio? 36. Oh no, I just done. Wait. Okay, R से R मर गया. Oh, 36. Then this is 18. This is probably 72. So, 2 equals to 36 5 1 7 into 9. 9 was 9. 9 was 9 was 36. 9 3 is 27, 9 was 36. So 5 is 20 upon 7. 20 upon 7, right? So this is 2. This is 2. 13. It is 2. Another mistake is 17.4. Dos. को 4 to 4 आया. मेरा कितना आया था? 2 आया था obviously. So let's do it again. H nu minus 5. ये था. Multiplied तो नहीं था I guess. Where is the formula shit? माइनस ही तो था. तो मैंने क्या किया? मल्टीप्लाई किया होगा ना ऑब्वियसली. इतना नंबर को कौन ही हो सकता है? See how messy things are getting. Electron volt. How many electron volt is given in the question? Where is the question now? An electron in a hydrogen atom jumps from excited state n equals to n excited state n to the ground state. Okay. The wavelength of emitted illuminates The wavelength so emitted illuminates a photosensitive material having work function that is minus 2.75 electron volt. This is energy, and we have this stopping potential. The stopping potential of the electron is 10 volt, E into 10 volt. Okay, so from here, E to it gone. E equals to 10 volt minus 2.75 volt. Hey, this is such a huge number. Okay, this will just get added. Oh my goodness. You. Here we have 10 volt, right? So then this one comes. This will get added. This will be like 11, 12.75 volt, which is basically n equals to 2. You just have to do 17. Nope, this is not given in electron volt. This should be in electron volt. Wait, this would be in electron volt. This is what you have got in volt. So when you have to convert this in electron volt, charge on one electron. That is this. Wait. Electron 10 V is equals to e to the power whatever 2.75 electron volt. Okay, 1.6 into 10 to the power minus 19, isn't it? Into 10. ये तो इलेक्ट्रॉन वोल्ट में ही है. So this will basically become 10 as 10 6 0 6 again. 10 1 10 16 into 10 to the power minus 19. Plus 2. Again, it is not coming anyway. E10, 16, 17, E10. I just wrote 4, 3, 16, 18, 17. I did it over here twice up to here. निधि अभी ना बहुत देर तक करेंगे क्योंकि मैं आज बहुत लेट उठी ना। मैं 5 बजे ही उठी हूँ कल रात सो के। तो आई थिंक मैं आज रात तो थोड़ा लंबा सेशन करूँगी क्योंकि मैंने दिन में कुछ नहीं पढ़ा ना। Somebody was Nepali. He is saying that he is also Nepali. जय गोरखा। ये जय गोरखा का मतलब क्या होता है? तो आई एम ऑल्सो नेपाली एंड आई डोंट थिंक व्हाट डज दिस मीन। जय गोरखा। There is a song on this, right? Gorkha. Isn't it army? But why he said this? Pain of regret. Nidhi is motivating me, huh? Thanks, Nidhi. Thanks, Harshita. How can you guys complete one chapter in just few hours? Somebody asked what happened. चार्ज खत्म हो गया था शायद इसलिए शिफ्ट हो गई। फिजिक्स जान लेती है? हाँ मेरा भी लेती है। वैसे तो मेरा सारा ही सब्जेक्ट लेती है लेकिन फिजिक्स और भी ज़्यादा लेती है। ओए आदर्श, आई नो यू आर देयर क्योंकि तूने ना किसी को हाइड या फिर कुछ कर दिया है। थैंक यू। और कल के लिए सॉरी। हाँ आदर्श, इफ़ यू आर देयर। मैंने पहले भी बोला सॉरी लेकिन तब तुम सेशन में नहीं थे शायद, लेकिन अभी भी बोल दे रही। आई एम सॉरी। आई वाज जस्ट मैड, आई डोंट नो व्हाई, क्योंकि मैं अच्छे से नहीं सोई थी ना शायद इसलिए। ये अच्छी बात है ना, क्योंकि आदर्श मॉडरेटर है तो ना मैं नेगेटिव कमेंट पर ही नहीं पा रही, क्योंकि उसने किसी श्रेया को भी हाइड कर दिया। उसने क्या लिखा ना मुझे पता नहीं, गलत ही लिखा होगा तभी हाइड हो गई। नहीं, यू आर नॉट देयर। निधि थी सिर्फ तब व्हेन आई सेड सॉरी। आई थिंक निधि लेफ्ट, राइट? निधि बिना बोले ही चली जाती है। कल भी शी डिडंट सेड एनीथिंग एंड शी वेंट। नाउ आई हैव टू डू अनदर चैप्टर। And then Bohr nature. Which do I have? 14%. क्या क्या आ रहा? Did you find it funny? Thank God you heard that. Because वो पता नहीं कैसा था ना, funny ही था, kind of. But I thought you will not come क्योंकि मैंने तुम्हें remove ही कर दिया था ना ग्रुप से, इसलिए I thought you will not come. मैं उससे पहले वाले दिन में ना नहीं सोई थी, रात में भी नहीं सोई थी, दिन में भी नहीं सोई थी। तो मैं अराउंड 5 सोई रात को इवनिंग में, और फिर मैं 9 पे उठ गई। 5, 6, 7, 8, 9 अप्रॉक्सीमेटली 5 आवर। तो मुझे कुछ ठीक से याद नहीं था, 5 में भी नहीं, शायद 6 पे सोई थी। तो फिर मुझे लगा कि मुझे और पढ़ना है, मुझे और पढ़ना है, एंड यू आर डिस्ट्रैक्टिंग मी आउट बकवास बातें लिख के। तो आई वॉज गेटिंग पिस्ड ऑफ। वो क्योंकि मैंने प्रॉपर रेस्ट नहीं लिया था ना, इसलिए ऐसा हुआ। लेकिन मैं अराउंड 3 सो गई थी कल, हाँ आज के सुबह। तो मैं सिर्फ अराउंड 5 उठी। माई ब्रदर वॉज लाइक यू विल नॉट कम टू कोचिंग टुडे, एंड आई वॉज लाइक हाँ रात भी हो गया। तो मैंने एक क्लास स्किप किया, दूसरी क्लास में मैं गई। आई होप तुमने ये भी सुना होगा ना तब। नाउ लेट्स स्टडी, ओके। लेकिन निधि कितना अच्छी थी ना, उसने कितना अच्छे तरीके से कंसोल किया कि हाँ इट्स ओके, फ्रस्ट्रेशन से होता है। यू डोंट हैव टू एक्सप्लेन एवरीथिंग मम्मा, जस्ट स्टडी। -15 meter 1.2 into 10 to the power minus r not क्यूब फोर में मलाई हुन्छ 1.2 for me 1.2 for me 1.2 into 10 to the power minus 15 1.2 into 10 to the power minus 15 meter. I'm just dumbass. Now just focus here. 1.2 into 10 to the power minus 15 meter, okay. R naught e to the power 1 by 3 ratio of r1 upon r2 is equals to a1 upon e2 3 or r1 upon r2 a1 upon e2 power 3. This is 8 to 2 को क्यूब करते हैं 8, 3 को क्यूब 27, 4 को क्यूब this is 64 if I'm not wrong, 5 को क्यूब 125 and 6 को क्यूब is 216, isn't it? Yep, it is. Here the value is 1.7 for me, which is also 1.7 into 10 to the power minus 15 meter. Not 1.7, that is 1.2 1.2 1.2. (1.2 into 10 to the power minus 15, 1.2 into 10 to the power minus 15, 1.2 into 10 to the power minus 15. Study, all you have to do is study, study, study. Two, 1, 6. इलेक्ट्रॉन वोल्ट में दिया है, जूल में कन्वर्ट करना है तो एनर्जी इन इलेक्ट्रॉन वोल्ट मल्टीप्लाई बाई 1.6 इंटू 10⁻⁻19 होगा ना, 9 जूल। इसको इलेक्ट्रॉन वोल्ट में कन्वर्ट करना है तो एनर्जी इन जूल अपॉन 1.6 इंटू 10⁻⁻19 इलेक्ट्रॉन वोल्ट होगा, जो भी आएगा। एनर्जी इन जूल में आएगा तब इलेक्ट्रॉन वोल्ट तो गलत कर दिया तुमने ना। जब एनर्जी जूल में चाहिए तो जो एनर्जी को इलेक्ट्रॉन वोल्ट में दिया है उसे मल्टीप्लाई करना है 1.6 इंटू 10⁻⁻19 से, तो एनर्जी आएगा जूल में, क्योंकि इलेक्ट्रॉन वोल्ट में जो एनर्जी है दिया है उसे जूल में कन्वर्ट कर रही हो, तभी तो ऐसा हो रहा है ना। एनर्जी इन जूल, एनर्जी इन इलेक्ट्रॉन वोल्ट इंटू 1.6 इंटू 10⁻⁻19। इलेक्ट्रॉन वोल्ट में एनर्जी दिया है, उसे 1.6 इंटू 10⁻⁻19 से मल्टीप्लाई करोगे तो जूल में आएगा एनर्जी। एनर्जी इन इलेक्ट्रॉन वोल्ट चाहिए, जूल में दिया है तो उससे डिवाइड करो 1.6 इंटू 10⁻⁻19 से, तो एनर्जी इन इलेक्ट्रॉन वोल्ट होगा ना। करेक्ट करेक्ट करेक्ट। इसके बाद क्या था, ये बाइंडिंग एनर्जी को Q से रिप्रेजेंट किया जाता है। बाइंडिंग एनर्जी पर न्यूक्लियन क्या होगा, स्टेबिलिटी। तो सबसे ज़्यादा स्टेबल कौन, 56 Fe 56, 8.5 मेगा इलेक्ट्रॉन वोल्ट। न्यूक्लियर, हाँ इसी में ही है रेडियो एक्टिविटी वाला पार्ट भी। ओहो नाइस। तो बाइंडिंग एनर्जी पर न्यूक्लियन फॉर मास नंबर ग्रेटर देन 30 पर लेस देन 170, इन सब का कितना होगा, 8.0 मेगा इलेक्ट्रॉन वोल्ट। ये भी स्टेबिलिटी में जाएगा, दोनों ही क्या होगा, स्टेबल। ये भी स्टेबल है, ये भी स्टेबल होगा। अब रिमेनिंग जिसका एटॉमिक मास 30 से कम होगा, और जिसका मास नंबर 170 से ज़्यादा होगा। इन दोनों ही क्या होगा, ये वाला पार्ट जिसका मास नंबर कम है 30 से, ये क्या करेगा, फ्यूज़ करेगा। तो जिसका मास नंबर जो 170 से ज़्यादा है वो क्या करेगा, फिजन। दोनों ही प्रोसेस में एनर्जी रिलीज होगी। You're going, Adarsh? It's just 11. Are you going? Or you already left? Adarsh? You're going? It's just 11:05. Are you going? Oi, type fast. But it's just 11:05. You don't sleep this early, do you? I thought you sleep at around 3 a.m. But you have decided to sleep early, right? I think you're trying to be a morning person. Hello, Shubham. You'll try to? What does that mean? You'll try to sleep? Or you are going to study? I'm not understanding anything. You'll try to sleep. Okay. But don't close the live session, okay? Because whenever someone will come and say something, you have to hide them. Okay, Adarsh. Bye. My moderator is leaving. Nice. 1 into mass of proton plus number of total neutrons. Mass of neutrons should be greater than m dash. DAUGHT are daughter nuclei. Okay. Short range. .8 for me. Ha ha ha. 0.8 for me से ज़्यादा तो attractive. Attractive 0.8 for me से कम तो repulsive. distance dependent. Distance dependent, and then charge independent. Do not depend on charge, right? And then it has spin dependent. Same sense of spin. Higher nuclear force, stronger force between them, and then nucleons having opposite sense of spin. Attractive, repulsive. Very much dependent upon distance. Small variation in distance may cause a large change in nuclear force. न्यूक्लियर फोर्स तो सेम ही होगा, इलेक्ट्रोस्टैटिक फोर्स प्रोटॉन में कम होगा, बाकी दोनों तो ठीक ठाक ही होगा. That's it. 3 to 4 for me. 3 to 4 for me. Okay. Listen. Okay. Binding energy per nucleon. कुछ ज़्यादा मुझे करना था. Binding energy per nucleon. आयरन को स्टेबल, जिसको वैल्यू ज़्यादा आती है वो स्टेबल के लिए स्टेबल. Product minus constituent. Binding energy of product minus binding of energy of constituent on the rest. Okay, this is one more. Binding energy of product, binding energy of constituent. For such, I don't know, for single P or single neutron, for single proton or single neutron. Binding energy is just 0 onsa usko lage. I think I will forget the small things. Hydrogen answer B equals to 0. Stability curve. Nuclear stability curve. इससे ही तो होगा. क्या होगा? Radioactivity start. देखो मैं पता नहीं. Nuclear stability. Neutron to proton ratio for lighter nuclei is equals to 1. between 1 to 1.5 or lighter. LIGHT are lighter nuclei. Heavier nuclei. Neutron to proton ratio of neutron. Okay, for lighter nuclei it is equals to 1, and for heavier it is in between 1 to 1.5. Conclusion. Nuclei having N by P ratio in the range of stability curve or stable nuclei radioactivity. Alpha, beta, or gamma हुन्छ. That's it. Alpha decay के हुन्छ. Now just write it down. I think I'll mess everything up. मैंने पढ़ा ही नहीं 11th फिजिक्स, और जब ये 12 फिजिक्स कंप्लीट करके मैंने देखा है ना, तो भी मुझे ऐसा लग रहा है कि सब कुछ नया नया पढ़ रही हूँ. नींद आ गई ना, अनि किन जोकर जस्तो गरिदिएको हो. गरम भयो, तर आमाले राम्रो कलरले म्याच गर्यो है. यतिकै हिँड्नु न. राम्रो त छ त. कति नुना देखिरहेको छ है. के ल्याइदिनु आफैलाई भन्नु त, मेरोमा 700 छ. बेसी चाहिँ त्यो पैसा चाहिँ तैँले लुगा लिएर एउटा पेन. कस्तो मैला लुगाहरूमा काम गरेर ल्याएको त्यो पनि सारा काँचालाई दिन्छु लुगा किन्ने भयो. अल्फा डिके. अल्फा डिकेमा के हुन्छ भन्दा त कुनै पनि एउटा एक्स छ भने यसको मास नम्बर ए हुन्छ, एटोमिक नम्बर जेड हुन्छ. यो के हुन्छ एक्स ए -4 हुन्छ, किनकि एउटा अल्फा एटम निस्किन्छ जो हिलियमको पार्टिकल हो. जेड -2 निक्लिन्छ. ओके, देन वी हेभ अल्फा डिकेमा के हुन्छ हिलियम अल्फा पार्टिकल हिलियम 4 2. ओके, अनि अझै एउटा के निस्किन्छ एनर्जी, जसलाई क्यू पनि लेख्न सक्छ होला. बाइन्डिङ एनर्जी क्यू रिलिज हुन्छ ह्युज अमाउन्टमा. एम आई राइट? यप, यू आर राइट. पेरेंट न्यूक्लियाई एटॉमिक नंबर 2 से कम होगा डॉटर न्यूक्लियाई का, और मास नंबर 4 से कम होगा. करेक्ट. दिस इज अल्फा पार्टिकल न्यूक्लियस अफ हिलियम, जसमा के हुन्छ प्रोटोन 2टा हुन्छ, न्यूट्रन 2टा हुन्छ, इलेक्ट्रोन हुँदैन. ह्युज अमाउन्ट अफ एनर्जी रिलिज हुन्छ. देन वी हेभ बीटा डिके और बीटा नेगेटिभ डिके, बोथ आर सेम. बीटा नेगेटिभमा के हुन्छ भने त हाम्रोमा एक्स छ जसको मास नम्बर 8 छ. जेड नेगेटिभ भनेपछि +1 आउँछ. अपोजिट हुन्छ नि त्यसको केसमा. एक्स ए ओके जेड +1. मास नम्बर सेम रहन्छ, एटोमिक नम्बर के हुन्छ चेन्ज हुन्छ, एक बढ्छ हो. प्लस यहाँनिर के आउँछ न त बीटा पार्टिकल जसको नेगेटिभ मास नम्बर 0. -1. It is -1. Then again anti-neutrino particle. Is it? Yep, it is. I think it is beta particle, beta decay or beta negative decay. Z +1 बीटा पार्टिकल -1 हुन्छ यसमा त, प्लस एन्टी न्युट्रिनो. अगर यो बीटा पोजिटिभ डिके भएको यसमा के हुन्थ्यो, अगर यो बीटा पोजिटिभ डिके भएको भए चाहिँ नि यसमा हुन्थ्यो हाम्रो एक्स जसको ए जेड छ. ए जेड -1 हुन्छ प्लस e⁻0 + 1 यो बीटा पार्टिकल हो. एन्ड देन न्युट्रिनो फर्म हुन्छ यसमा. के फर्म हुन्छ न्युट्रिनो. बीटा प्लस डिकेमा के हुँदैछ ल हेर. n by p ratio हुँदैछ ओके z minus 1 भनेपछि प्रोटोन तिम्रो के गर्दैछ डिक्रिज हुँदैछ के बढ्दैछ न्यूट्रॉन n by p रेशियो भनेपछि के भयो ठुलो आयो इन्क्रिज हुँदैछ n by p रेशियो के हुँदैछ इन्क्रिज हुँदैछ बीटा पोजिटिभ डिकेको कुरा हो यो चाहिँ एन्टिन्युट्रिनो यसमा के निक्लिँदैछ बीटा नेगेटिभमा न्युट्रिनो नो बीटा नेगेटिभमा एन्टिन्युट्रिनो यसमा न्युट्रिनो हुँदैछ यु आर करेक्ट हिमा यु डोन्ट ह्याभ टु पुट दिस न्युट्रिनो आपका नीट का क्या स्कोर था 2024 में नॉट मोर देन 200 और समथिंग 300 तो नहीं था बीटा पॉजिटिव डिके बीटा पॉजिटिव डिके में कितने बनाना z minus 1 plus neutrino for such atom for single pair single neutron for single proton or neutron लेगा हाँ बीटा नेगेटिभ डिकेमा के हुन्छ भन्दा त नम्बर अफ प्रोटोन र नम्बर अफ न्युट्रोन बीटा डिके यहाँ के हुँदैछ यसमा z plus 1 n by p रेशियो प्रोटोन के हुँदैछ इन्क्रिज हुँदैछ एन के हुँदैछ न्युट्रोन डिक्रिज हुँदैछ मिन्स के हुन्छ n by p रेशियो डिक्रिज हुन्छ n by p रेशियो डिक्रिज हुन्छ ओके हर्षिता आई एम ग्लैड कि तुम अभी तक पढ़ रही हो आई थॉट यू स्लीप्ड number of alpha and beta particle. This is not in general, okay? Z in Z1, right? E2 Z2 plus He plus binding energy. In general, X. E1 equals to E2 plus E times 4 plus B times mass number का किसा 0 सा E1 minus E2 equals to 4A plus 0. 4A equals to A1 minus A2. A equals to A1 minus A2 upon 4. तुम्हारा कल क्लास है तो तुम्हें सोना चाहिए, लेकिन हर्षिता कंप्लीट जल्दी जल्दी करके सो जाना, क्योंकि कल स्कूल भी जाना है ना, तो तुम्हें सुबह जल्दी उठना पड़ेगा. हाय अनिल. E equals to A1 minus A2 for number of alpha particle. A1 minus A2 upon 4. So basically I have to remember this. A. This is X. A. E1 Z1 equals to X. E2 Z2 plus He42 plus B plus 1. You can write minus 1 also, okay? From here, number of beta particles. Number of beta in beta positive. In beta positive, that is the beta positive. इसमें क्या करना था? B Z1 equals to Z2 plus A times 2 plus B times 1. So we have to search this Z1, Z equals to Z2 plus 2A plus B. From here we have to calculate B. Z1 minus Z2. Okay. 2A. This is multiplication, but this is plus sign, right? So we have to write minus of 2A, Z1 minus Z2 minus 2A. Total number of beta positive, Z1 minus Z2 minus 2A, correct? Now for again, we have to number of beta particles in beta negative decay. Write down the E1 Z1 equals to E2, this is X, Z2 plus skin से बना था यहाँ E times HE4 2 and then B times plus B times, if this is beta negative decay, then we have minus 1. E1 equals to, not E1, we have to just write Z1 equals to Z2 plus, because E1 will remain E1 only here in this case, okay? E times 2 times E plus B times minus 1. Oh, from here I can write that Z1 minus Z2 equals to 2 times A minus B. Really? So from here I can write B equals to Z2 minus Z1 plus 2A. Z2 minus Z1 plus 2A, correct? Number of beta particles. Can you solve it? What can I solve it? No, I can't solve it. Show me the question, but holidays for me, Didi. Okay, Harshita. She is asking. Harshita. Okay. Ask whatever you want. I thought you were asking me. Then this left for the Shira. All about politics. Rutherford and Saudi decays law. N equals to N naught e to the power minus lambda. Valid only for large sample. Rutherford and Saudi's decay law is only valid for large sample. Okay, nuclei radioactive decay करता है तो फर्स्ट ऑर्डर रिएक्शन को फॉलो करता है. ओके, डिके कांस्टेंट ज़्यादा, उसका रेट ऑफ डिके ज़्यादा मतलब अनस्टेबल, रेट ऑफ डिके ज़्यादा मतलब अनस्टेबल. ओके, डिके कांस्टेंट ज़्यादा मतलब okay. So kinetic energy of alpha particle, kinetic energy of daughter nuclei, and velocity of recoil of daughter nuclei. I am a dropper. I don't go to school. Now you can ask if you want to. वैसे भी मेरे पास इतना टाइम नहीं है, जल्दी पूछ लो. What kind of question is that? Let me see. Vincent. Are you there, beginner Karam? I'm waiting for your question. If you are there, just write it down. Three to 4 days for Puja holiday. I don't know, I just don't have calendar in my house. I'm not sure. I think 3 to 4 days is enough for students. I think I should buy a calendar. I think this guy left, right? Beginner Karam, because he is not asking his question. I have been waiting for almost 1 minute. No, I don't remember. For a minus a upon 4. 4. Ha. Everything wrong. Sin 30 times 90. 1 by 2 into not defined. That is not defined only. That was your question, no? You are not beginner Karam. I think the person who is asking this question is Imam. I think the answer to this question is not defined. Or, yeah, if we multiply something with not defined, that is not defined, then the answer will be not defined. Or infinity or 0, whatever you want to say. माइनस अल्फा पार्टिकल। B dash B dash A minus 4 is equals to M को जब हम मास कर दीजिए 4M V। V dash is equals to पॉजिटिव बनती है ना, ये यहीं है छोटे के बाद। फोर एम वी माइनस फोर टाइम्स वी माइनस 4। हाँ सेवेंटी के अराउंड हर्षिता। हाय गंधर्व, गुड नाइट हर्षिता। हाउ इज द स्टडीज एंड फिजिक्स है, गंधर्व भी है। वो ऐसी बात है तो ठीक है गंधर्व। मुझे नहीं पता इमाम। हाय गंधर्वा। ओके गंधर्वा, कैन स्टडी विद मी, क्योंकि मैं भी आज ना इवनिंग में ही उठी हूँ, तो मे बी होल रात पढ़ूंगी शायद, क्योंकि मैंने दिन में नहीं पढ़ाई किया ना, मैं नहीं पढ़ पाई। तो लेट्स स्टडी। इमाम, तुमने जो पूछा मुझे नहीं पता, तुम खुद ही आंसर दे देना, ठीक है? लेट्स स्टडी। गुड लक गंधर्वा। Thorium. P initial. MV square. I think it's MV square. It's just MV, moment of mass into velocity. V square. इसका जो मास है V डैश होगा प्लस माइनस V, तो इसमें होगा 4mV माइनस mV E माइनस 4 टाइम्स m, 0 0 के। फोर V माइनस दिस इज V डैश V dash A minus 4 V dash A minus 4 is equals to 4V. So V dash is equals to 4 times A minus 4 upon A minus 4 times V, which is also known as V dash is equals to 4V upon A minus 4. A minus 4 upon A times Q. Kinetic energy of daughter nuclei is equals to 4 upon A times Q. 4 upon A times Q. A minus 4 upon A times Q for kinetic energy of alpha particle. Okay. ऐसे तो मैं नहीं बता सकती गंधर कब तक पढ़ूंगी, लेकिन ना मैंने बताया ना मैं 5 पे उठी हूँ, इवनिंग के 5। आई स्लेप्ट होल डे, तो आई थिंक अप्रॉक्सीमेटली अप्रॉक्स बता रही हूँ, आई एम नॉट श्योर, लेकिन टिल 3 तो पढ़ूंगी ही पढ़ूंगी, क्योंकि वैसे भी मुझे नींद नहीं आएगा, सोने जाऊंगी भी, तो इंस्टेड ऑफ वेस्टिंग टाइम आई विल स्टडी हियर ओनली। सो इफ़ यू वांट टू स्टडी यू कैन स्टडी विद मी। सिक्किम में एक कॉलेज है SRM यूनिवर्सिटी करके, नॉट मोर देन 200 और समथिंग, बहुत कम था। नाउ आई थिंक वी शुड स्टडी, वरना इस बार भी कम ही आएगा। Alpha particle is equals to A minus 4 upon binding energy is absolute of 1 proton and neutron. बाइंडिंग एनर्जी पर न्यूक्लियन ग्राफ भी बना सकते हैं. बाइंडिंग एनर्जी वर्सेस मास नंबर. N by P ratio 1 lighter nuclei, N by P in between for heavier 1 to 1.5. Velocity with which daughter nuclei recoil. Minus 4 times Q. Beta decay or beta negative decay. Okay, Gandharv. Z plus 1 A X A Z Y A Z plus 1 minus 1 0. रेशियो डिक्रीज होगा ना, स्टेबिलिटी जोन में आएगा. प्रोटॉन बीटा पार्टिकल और एंटी न्यूट्रिनो. न्यूट्रॉन बीटा पार्टिकल एंड न्यूट्रिनो. Gamma photon high frequency energy release, high penetrating power. Gamma photon high frequency, high energy and high penetrating power. Z2 minus Z1 plus 2A. Z1 minus Z2 minus 2A. Z1 plus 2A. And now 0.693. Area is of rock and times half-life. कति half-life बितेको छ? Number of half-life हामीले बताउँछ. Okay. Critical condition in which nuclear reactor works. Less than 0, reaction will end. Greater than 0, multiplication factor हो यो. Okay. Bomb. Cathode. Cadmium, not cathode. Cadmium. Fusion. Greater than fission. Okay. 92. Then barium को 141. Krypton को 92. H2O-D2O graphite slow down the neutron. Control chain reaction slows down the neutron. 23.8 upon A. How much? 4. 1, 2. 4, 1, 4, 4, 4, 20, 4, 6, 24. If it is 2, then 2 ones are 2, 2, 6, 7, 9, 13. Recoil given fraction, decay given in the fraction, 1 minus given fraction and not. Gandharv, if you are still there, keep studying. I'll go make some tea for myself and then I'll return back. Okay, till then you keep studying. Don't get distracted. It's just 12, not even 12, 11:56. So I think. Keep studying, okay? I'll go and make a cup of tea for myself. मॉर्निंग आई गो टू एलन एंड इवनिंग एलन की तो क्लास ना अराउंड 7 ही हो जाते हैं ना गंदर. लास्ट टाइम मे बी आकाश में टेस्ट सीरीज के लिए जाती थी ना, तो आई यूज टू सी एलन स्टूडेंट गोइंग टू द इंस्टीट्यूट अराउंड 7. आई थिंक 7 से ही स्टार्ट होता है. आकाश तो 9 से होता था. यू मस्ट बी वेरी स्मार्ट देन. एलन के जो भी बच्चे होते हैं ना, वो लोग बहुत स्मार्ट होते हैं. आई डोंट नो फॉर सम रीज़न. हाँ, तभी तो तुम्हें तो जल्दी उठना पड़ेगा. फिर तो तुम 3 पे सो के 7 पे कैसे उठ के क्लास जाओगे. पीडब्ल्यू के कौन सा बैच है तुम्हारा ऑनलाइन. यकीन. अर्जुन अर्जुन और अर्जुना, ये तो क्लास 11th के लिए होता है ना. शायद मैं गलत हूँ, लेकिन मुझे ऐसा लगा. फर्स्ट वन. Oh, so you are in class 11. When I was in class 11th, मुझे तो पता भी नहीं था कि पढ़ना होता है. आजकल के बहुत बच्चे बहुत स्मार्ट हो गए, 11th से ही पढ़ते हैं. नहीं, शायद तभी भी टॉपर्स लोग वैसे ही करते थे होंगे ना. मुझे नहीं पता था. आई एम फर्स्ट ईयर BSc. You also had coffee, okay. I made tea, but you can't see. I'm so sad. Can you see? No, you can't. If I show it more, then the tea will spill all over here. PCMB need. Okay, so you have both bio and math. I left mathematics since class 10th. This is not coffee, okay? This is tea. Just give me a suggestion. Should I revise semiconductor, nuclei, or dual nature? Which one? It's okay. Which one should I revise? Okay, I'll revise dual nature, but before that, I have to practice some questions from nuclei. Then I'll revise dual nature. वैसे भी आज तो इतना ज़्यादा पढ़ना है. Which module are you using? ये वाला. ये आकाश का है. जब मैं आकाश में थी ना, तब उन लोगों ने दिया था. तब तो यूज़ नहीं किया, अभी यूज़ कर लेती हूँ. क्योंकि तब ना टीचर भी ऐसे ही थे और हम लोग भी ऐसे ही थे, तो सब कुछ ऐसा लग रहा था कि पता नहीं क्या चल रहा था. लीव देम. कुछ भी नहीं पढ़ा तब तो. अभी सॉल्व करना पड़ेगा इस मॉड्यूल से. 103. Let's study, okay? All the best. Good luck for the next session, bro. the ratio of radii. Mass number 27 upon 125. That is 3 upon 5. 3 to the 6, 5 to the 10. The energy equivalent of 0.5 gram of a substance is 1.6 into 10 to the power minus 19. 0.85. Oh. C square डेल एम सी स्क्वायर, इसको केजी में कन्वर्ट करना होगा ना पहले तो. -3 into 10 to the power 8. 5 into 10 to the power 5 into 15. 4. 1.6 into 10 to the power minus 24. Three five is 5 बने तो है ना. 10 to the power 5. तो जोल पर सेकंड में आना है. डेल एन सी स्क्वायर. Nine into 0.5 into 10 to the power 16 minus 3. 4.5 into 10 to the power minus 16. Oh no. 13. 14, 15, 16. 13 joule, right? मैंने शक्कर ही नहीं डाला. It's not that nice. I like the taste of coffee. But coffee कितना expensive है तुम्हें पता है ना? For a cup of coffee, we have to pay 60 rupees. In 60 rupees, so I can drink 6 cup of tea. I think you also like the taste of tea, coffee, right? One, two. Oh, nucleus so important. You want to? मैं रेसिपी बता दूँ क्योंकि ऐसे तो पॉसिबल नहीं है ना. तो you have to put water, then tea, then इलायची. मैंने इसमें शुगर नहीं डाला लेकिन डालना चाहिए. एंड देन यू हैव टू बॉईल जिंजर और ना बे लीफ है तो और भी अच्छा होगा, लेकिन मैंने इसमें बे लीफ भी नहीं डाला, जिंजर भी नहीं डाला. तो जितना ज़्यादा तुम चाय को उबालोगे उतना ही टेस्टी बनेगा. ओके. आई शुडंट स्माइल लाइक दैट, है ना? Now I think I have to study and you also have to study. Let's study. Z+1. मोटिवेशन दे दो, मुझे भी देना, कहीं मिल जाए तो ठीक है, थोड़ा मोटिवेशन, ताकि मैं भी मोटिवेट हो जाऊँ। The fraction of original activity that will remain. .6. Nine one two. binding energy for nucleon of unreacted nuclei is 2.7 giga-electron-volt, while that of fragment is Thanks, Gandharv. I pray for that, Gandharv. One point 10 to the power 4. Big Baron 6 को 4. The rate of radioactive disintegration मतलब radioactive decay. Instant. The number of radioactive atoms in that sample at that instant is alpha particle consists of 2 proton and 2 neutron only. For a radioactive material, half-life of a minute is 10 minutes. If initially there are 600 number of nuclei, the time taken in minute for the disintegration of 450 nuclei. $150 is remaining. Four. I'm getting distracted again and again because of my thoughts. What should I do? Just focus here, Ima. Yeah, I have to stay focused. I don't know. My mind is roaming in future. Not even in past, not even in present. Hmm. It's okay. Don't roam. Don't roam. Don't roam. Rom-com. Rom-com. A nucleus with mass number to center. Hey, this is something else. 1 minute. Let me do this again. Binding energy per nucleon. Where is it? It's not here. It's here. Binding energy per nucleon. Nucleon का कितने का जमाना नाम है? 240. 240 breaks into unfragmented को this is 7.6 है ना. The total gain in binding energy 24 into 76. 717, 72, 10, 78, 21, 28. 2 7 14, 15. 2, 8. 1820. Hey? Huh? Ooh. Did I just did the silly mistake? You're binding energy per nucleon. How much it is? It was 8, it was 16, 17. 8, 2 5s are 10 को 0 1 तक है ना. 8 was 8, it was 16, 17, 170. 1 5s are 5, 1 8s are 8. 0, 10, 11, 12, 12 को 2, 1 is okay. 8, 9, 10, 1 0 2 0. $820, it is also given. 8.5 into 240. 16, 18, 4 is 32, 33, 34. 5 1 is 5, 5 2 is 10. 8 1 is 8, 8 16, 17. 1 7. 0 4 7 8 9 10. No. ये तो डिक्रीज हो रहा. Think about this. I will read like only. I'm messing up with my questions and my calculation. I have to use calculator. 240. 1824. 7 1 2 240 into 7.6, right? 4 5 is 20, 4 6 is 24. Go 4 2 is 7 1 7, 7 2 14, 7 3 is 21, 7 4 is 28, 29 30, correct. 2 6 is 12. Go 2 1 is 2 7 is 14, 15, 0 2. How come? Shay. 1824. 214. 6 zeros are 0. 6 1 is 6, 6 2 is 12, 6 3 is 18, 6 4 is 24. 6 6 12 6 18 6 24. 6 12 13 14. 7 zeros are 0. 7 just 14 7 3 1 7 4 is 28 go 8. 2 is the winner. 7 1 7 7 14 15 16. 0 4 8 9 10 11 12 12 go 2. 1 is the winner. 6 7 8. 18240. 4 5 is 20, 4 6 is 24. 4 5 is 20, 4 6 is 24, 4 7 is 28, 29 30. 2 5 is 10, 2 6 is 12. Hey bro, here it is 4, not a 0. 1824. We have 7 point, not 7 point, it's how much? 8.6, right? Eight point five into 240 is equals to 2040 minus 1824 equals to 216. यही तो है आंसर, फिर क्यों नहीं आ रहा? Two zero four zero 1 8 6 1 2 216 मेगा इलेक्ट्रॉन वोल्ट। दिस इज न्यूक्लियाई, वो हाफ लाइफ वाला है ना, वो है, लेकिन फिर भी नहीं हो रहा मुझसे, स्पेशली ये जो हाफ लाइफ वाला सेक्शन है ना, और ये रेट ऑफ डिसइंटीग्रेशन, उसका क्या बोलते हैं, एक्टिविटी, राइट। एक्टिविटी और हाफ लाइफ के क्वेश्चन ना मुझसे इतनी मुश्किल से होती है। और देखो ना, अभी तो मेरा कितना सिली मिस्टेक हो गया। बाइंडिंग एनर्जी पर न्यूक्लियन, यही वाला मैंने यहाँ पर सॉल्व किया था ना, मैंने मल्टीप्लिकेशन में ही मिस्टेक कर दिया। आई थिंक माई माइंड इज स्लीपिंग। अगर मैं अभी सोने गई ना तो भी मुझे नींद बिल्कुल नहीं आएगी। आई वॉन्ट स्लीप टिल morning. I know that. I'll just scroll. Even if I don't scroll, I'll just keep awake in my bed. You know, ray optic oscillation. हाँ, हाँ, सब लोग बोलते हैं रे ऑप्टिक्स टफेस्ट है ना, क्योंकि वो भी बोल रहा था, आदर्श भी बोल रहा था रे ऑप्टिक्स टफ है। टफ लगा। मैंने लेसन पूरा कंप्लीट किया है ना, लेकिन मुझे रिवाइज करने में ही याद आता है, तो मैंने उसका पूरा कंप्लीट रिवीजन नहीं किया। स्पेरिकल वाला मिरर, वो स्पेरिकल मिरर किया है, comes in second. PU, what's that? मैंने उसमें से कहाँ तक रिवाइज किया है, प्लेन मिरर किया है, स्पेरिकल वाला किया है, मैंने लेंस पार्ट नहीं किया है, प्रिज्म किया है, और तो क्या बचा उसमें, प्रिज्म, 2 मिरर, रिफ्रैक्टिव इंडेक्स वाला भी किया है। हाँ, मेरा लेंस और ना ऑप्टिकल इंस्ट्रूमेंट वाला बाकी है। तुम तो क्लास 11th में हो, तो तुम्हें 12th का पोर्शन क्यों कराया जा रहा है? हाँ, तो तुम लोगों को क्यों कराया जा रहा है अब? एलिन सच्ची में प्लेन के स्पीड में सिलेबस भगाता है क्या? समझ में आ रहा है तुम लोगों को रे ऑप्टिक्स? लेकिन आ जाएगा, क्योंकि तुम वो रे ऑप्टिक्स वाला सेम पोर्शन क्लास 10th में भी है ना। 10th में बस ऑप्टिकल इंस्ट्रूमेंट नहीं दिया होगा शायद, या फिर वो भी दिया हो, ह्यूमन आई और समथिंग में, लाइट में तो नहीं दिया है। हाँ, हाँ, मैंने तो लेंस वाला पोर्शन रे ऑप्टिक्स से। So tough. वाओ, फुल चैप्टर किया, वो भी अंडरस्टूड कम्प्लीटली नहीं। मैंने फुल चैप्टर किया, फिर भी मेरा लेंस बाकी है और ऑप्टिकल इंस्ट्रूमेंट भी रिवाइज़ करना है, और जो पोर्शन रिवाइज़ किया ना उसमें से भी फिर से रिवाइज़ करना होगा मुझे, वरना मैं भूल ही जाती हूँ। I'm kinda jealous of those students like you who just study and then they are like, okay, they can solve anything. I'm not like you all. I have to revise again and again the same thing. Okay, good for you, bad for me. Okay, let's study again. You're looking good. Huh? Now, am I looking bad? I wish मैं भी बोल सकती गंदर, लेकिन मैं तुम्हें भी बोल ही देती हूँ ना, यू आर ऑल्सो लुकिंग गुड गंदर। मैं तुमसे बड़ी हूँ, ऐसी बातें मत लिखा करो। वैसे भी मैं वो ही फील करने लग जाती हूँ, शाई शाई। हाँ, यू आर डू। Now let's study again. It's okay, Gandharv. I know you are just chilling. Now let's study. Radioactive material A has a decay constant 8 lambda and B has decay constant, okay, A equals to n lambda है ना, तो decay constant कितना दिया है यहाँ पर 8 lambda। B को decay constant and lambda. Initially they have same number of nuclei, okay. After that, what time the ratio of number of nuclei of material B to that A will be 1 by A. Is equals to 0.7 T min. That means कितना इनिशियल से 37% गायब हो चुका है। वन अपन लैम्डा 11 को 1 वाला। The half-life of a radioactive substance is 30 minutes. The time in minute taken between 40% decay and 85% decay. Thanks, Gandharv. Hi, Shakshi. The time in minute taken between 40% decay to 85% decay. जब 40% डिके हो गया होगा तो यहाँ पर कितना होगा? अगर टोटल 100 था, यहाँ पर 60% था, 60% था। %. 15%. वो डॉग ना मेरी अम्मा ने दिया था। अम्मा मतलब क्या होता है तुम लोगों की लैंग्वेज में? मदर, राइट? तो वो मेरी अम्मा ने दिया था, इसलिए मैं उसे नहीं फेंक सकती। दिस इज़ द ओनली गिफ्ट शी हैव एवर गिफ्टेड मी इन माई एंटायर लाइफ. सो मैंने उसको रख दिया ऊपर. Right? 40% and 85%. 40% देख के बता 15% रिमेन हो रहा है. एक हाफ लाइफ 30 मिनट होता है एंड इक्वल्स टू एन नॉट अपॉन. तो सिंपली जस्ट इन दोनों का रेशियो लिया जाए तो कितना होगा. फ्रैक्शन में दिया ही नहीं है ये. 2016. A nucleus of uranium decays at rest into nuclei of thorium and helium, then has less kinetic energy than that of thorium. एक थोरियम यूरेनियम है. More kinetic energy than thorium. Then the thorium nucleus. Recoil हुआ ना ये. The helium has more kinetic energy than the thorium nucleus. Nucleus has less momentum than more momentum than thorium nucleus. बताया नहीं. If a radius of 27, then the radius of this will be like then the radius of beryllium nucleus is nearly radius of R naught A 1.2 into 27. Three to 4. No, I wrote it wrong. This is R naught e to the power 3 होता है, I guess. 3, तो this is probably 1.2. radius of tellurium nucleus is this is nearly 5. Why the mass number is given? Five upon 7. 5 upon 7. 5 upon 3. REL. I think this is 3. The binding energy per nucleon of lithium and helium is nuclei are 5.60 and constituent this product yeah, I'm kind of sleepy, but I know whenever I go to bed I don't sleep. That's why I don't want to sleep. Beside that, अगर मैं सोई भी तो मेरा सिलेबस कच्चा ही रह जाएगा. दीदी पढ़ी के समय कैमरा फिक्स करके सिर्फ पढ़ाई पे फोकस करो वरना पढ़ाई अच्छी नहीं होगी. हाँ मेरी तो वैसे भी नहीं हो रही है. 3 तक तो पढ़ूंगी ही पढ़ूंगी क्योंकि ये चैप्टर ना बहुत लंबा हो गया है. क्योंकि मैं मॉडर्न फिजिक्स कब से पढ़ रही हूँ. सितंबर में भी मॉडर्न फिजिक्स ही पढ़ रही थी. और ये ऑप्टिक्स वाला पार्ट अलॉन्ग विद मॉडर्न फिजिक्स मुझे कम्प्लीटली रिवाइज करना है 5 अक्टूबर तक. उसके बाद फिर मुझे पार्ट 1 करना है ना, इसलिए. थैंक्स गंधर्व. हाय साजाद. You haven't slept till now. I am good. A bit sleepy and tired, but I will not sleep. Thanks, Gandharva. Let's study. मुझे तो लग रहा है कि मैं कम मेहनत कर रही हूँ. Yep, tea time. I think now we have to study, okay? Don't text anything. We just have to focus on the studies. Just study, 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 and study. Don't text anything. Till 2 a.m. Till 2 a.m. Nobody is going to open the chat section. We just have to focus on the studies. Let's study. T half ln 2 lambda. After n half-life number of concentration. There are initially radioactive element present in a container, and after 10 seconds number of undecayed nuclei is equals to initial n naught minus n from Rutherford and Soddy's decay law. Rutherford and Soddy's decay law. Rutherford and Soddy's decay. So n equals to n naught e to the power minus lambda t. And s is equals to n naught minus n naught e to the power minus lambda t. From here we can take the common as n naught 1 minus e to the power minus lambda t. Okay, and s equals to n naught 1 minus e to the power lambda t. This will be the total number of undecayed nuclei. This will be the total number of undecayed nuclei, correct? And not 1 minus e to the power minus lambda t. Half-life. Half-life. Time in which number of radioactive nuclei becomes half of the initial value. Time in which number of radioactive nuclei becomes the half of initial value. Initial value को exact half भएको हुन्छ जब radioactive nuclei त्यसलाई के भन्छ t half भन्छ के t half is given by ln2 log 2 upon lambda decay constant. Okay, the value of ln2 is equals to 0.693, which is approximately 0.7. Correct? So from here, t half is equals to approximate value of ln2 is 0.7 upon lambda. This is our another formula. N naught is initial, then after t half, after half life n naught, the value will be n naught by 2, and after second half life, the initial concentration of radioactive nuclei will become n naught upon 4. For third half life, n naught upon 8. This can be written as n naught upon 2 to the power 2, and this can be written as n naught upon 2 to the power 3. For nth half life, n naught and nth half life, n naught will become 2 to the power n. After the nth half life, n. Number of concentration of remaining or undecayed nuclei will become initial nuclei upon 2 to the power n. N is equals to number of times of half-life. Okay, so from here we can also calculate lambda. Lambda is equals to 0.7 upon t half. Okay, which can be again written as log 2 upon t half. This is the value of lambda, that is decay constant. N equals to n naught upon t to the power 2 to the power t upon t half. N, number of remaining nuclei, remaining nuclei. N equals to n naught upon 2 to the power t upon t half. Okay, lambda 0.7. Wait. And not upon t to the power lambda t to the power t half. T upon t half. I don't know from where this formula has been derived. Leave it. Mean life or average life, which is represented with Tm. Time after which number of radioactive nuclei becomes 1 upon E times of initial or original. 37% of initial. Time after which number of radioactive nuclei become 37% of the initial. If it becomes the 37%, okay. Is initial 60, 50, 15. The 5 and then 5 minus 1, 45. I think I'm kind of confused. Time after which number of radioactive nuclei become 1 upon E times of initial. 1 upon E times of initial, that is 0.37 or 37% of initial. Initial जति छ त्यसको 37%. 1 upon lambda, and not T mean, and not upon E to the power 2, and not upon E to the power 3, and not upon E to the power n. After n mean life, and not upon E to the power n. Relation between half-life and mean life or average life, Tm. You have to complete that, okay? T half ln2 upon lambda. T average 1 upon lambda. T average like लिख 1 upon lambda लिख obviously. How? So ln2 T average. T half is 0.7 into T average 1 upon lambda. Hundred and 60. You can do it. So tough. The binding energy per nucleon of 3 and helium nuclei are 5.60 mega electron volt. In the nuclear reaction, this is H1 1 0 होगा ना इसका तो mega electron volt product Q is equals to Q of product minus Q of constituent. Q is equals to 7.06 minus 5.60. The value of Q will be 6 4 1.46 electron volt or mega electron volt. It is given in mega electron volt. Then answer will be इसका तो एक ही है ना, तो ये तो डबल हो जाएगा, 2 टाइम्स हो जाएगा. 2 6 से 12 को 2 आने तक गया, 2 7 से 14 5.60 12 में 0 कटाउँदा खेर 2 0 कटाउँदा खेर 2 11 में 6 कटाउँदा खेर 5 13 में 5 कटाउँदा खेर 8 8.52 मेगा इलेक्ट्रोन वोल्ट. 3 15 को 3 decays to y. A sample of the rock from a cave was found to contain x and y in the ratio of 1:7. Here's a sample of rock from a cave was found to contain x and y in the ratio of 1:7. 1:7. Okay. So the initial is n naught upon 2 to the power 3. This is basically 8 na. 3 half-life and is 1.4 into 3. Okay. 3 4s 12. 4.2. 4.2 into 10 to the power 9 years. 4.2 into 10 to the power 9 years. 16 to 3. Still I'm not sure. But I don't have option. Just do it, bro. Just do it. 3. Right? 4.2 into 10 to the power 9 years. Now we have to 17. This one is 16, okay? 17. A certain mass of hydrogen is changed to helium by the process of fusion. The mass defect in fusion reaction is del m equals to 0.02866 u. मतलब AMU में दिया है ना. हाँ. U. Oh, this is the energy liberated per U is. इसको ही कर दो. Energy equals to del mc square. अगर 0.02866 into 931 मेगा इलेक्ट्रॉन वोल्ट आंसर है तो हमारा आएगा 0.02866 into 931 0.02866 3 5 से 15 3 6 से 18 को 8 बने तो गया 19 को 9 बने तो गया ना 8 1 8 16 8 24 25 को 5 2 तो गया 3 2 6 7 8 0 0 9 5 से 45 9 6 से 54 को 4 5 तो गया 9 6 से 54 54 55 6 7 58 59 9 को 9 5 तो गया 8 is 64 8 9 is 72 73 74 75 76 77 7 तो गया 9 was 9 9 to the 18 19 20 21 22 23 24 25 25 को 5 2 तो गया 0 1 2 3 4 5 6 12 13 14 10 18 19 20 22 10 15 18 16 6 2 oh 1 2 3 4 5 that is 26.68246 mega electron volt which is approximately 26.7 mega electron volt. 17 को 1. You're going to sleep, Gandharva? I'll talk to you after 2, okay, Gandharva? The half-life of a radioactive isotopes is T half equals to 20 years. The half-life of a radioactive isotopes X is 20 years. It decays to another element Y, which is stable. X decays to Y, which is stable, okay? The two element X and Y were found to be in the ratio of 1:7. Isn't this the same question? The age of the rock is the half-life. Given half-life is different. No, here it is 1.4 into 10 to the power 9 years. That means, what was our answer to that? 4.2 X to Y. 20 years. Then 1:7, right? In the ratio of 1:7. That means n naught upon 8. टोटल तो 80 है ना, 7 डीके हो गया है. I don't know, this is how I was taught. 2 to the power 3, that means 3 half-life. From here it will be like 20 into 3, which is equals to 3 0 0, 3 1 3, 3 2 6. 60 years. 18 को 1. Years. If the nuclear radius of aluminium 27 is 3.6 Fermi, the approximate nucleus of radius 64 is 1.2 into in Fermi is 1.2 into कति हुन्छ भने त 64 कपर को 64 भनेपछि त कति भयो के को पावर 64 हुन्छ 4 क्यूब r equals to r naught e to the क्यूब हैन r naught कति दिएको छ यहाँ हेरेर त 1.2 हुन्छ हो इन्टु a to the power 1/3 भनेको छ नि त. ओके गन्धर्व, just wait till 2, okay? a to the power 1/3 a क्यूब भनेपछि a कति दिएको छ 27 this is we are searching for 64 copper 64 को क्यूब हुन्छ 4 1.2 into 4 we have to do 1.2 into 4 which is approximately 4 1 4 4 2 8 4 1 4 4.8 for me 19 को 1. A mixture consists of two radioactive materials A1 and A2. Two radioactive materials, okay. Mixture consists of two radioactive materials A1 and A2 with half-lives of 20 seconds and 8 seconds respectively. Initially the mixture has 40 gram of A1 and 160 gram of A2. The amount of the two in the mixture will become equal after. This is great. A mixture consists of two radioactive material or sample A1 and A2, okay, with half-life. A1 को half-life कति छ T half भन्नु त 20 seconds. 20 seconds and 10 seconds T half 10 seconds रहेछ. इनिशियली द मिक्सचर हैज 40 ग्राम अफ A1. इनिशियली कति थिएछ 40 ग्राम थिएछ A1 and 160 ग्राम अफ A2. इनिशियली 40 छ 20 seconds भन्दैछ 4 2 1 20. The half-life of a radioactive nucleus is the half-life of a radioactive nucleus is 50 days. The time interval T2 to T21 between the time T2 when 2 upon 3 of it has decayed and time T1 when 1 upon 3 of it has decayed as the half-life of a radioactive nucleus कति छ 50 दिन छ. The time interval T2 when between the time T2 when 2 upon 3 T2 मा कति गरेको रहेछ भन्दा T2 मा चाहिँ नि 2 upon 3 डिकेड भएको रहेछ. डिकेड भनेपछि यसमा इनिशियल कति छ भन्दा त 1 minus 2 upon 3 that is 1 upon 3 remaining. 1 by 3 remain हो 2 by 3 के हुन्छ डिके. T1 मा के छ भन्दा त 1 upon 3 छ डिकेड. T1 मा T1 मा 1 minus 1 upon 3 3 1 3 that is 2 upon 3. This is undecayed छ. यो के हो T2 मा यति रिमेनिङ छ. T1 मा कति छ यति रिमेनिङ 50 डेज हो. T हाफ कति हो यसको the time interval between T2 to T1 between the time T2 when 3 of it has decayed and decayed as 50 days हो. 21 को 50 days हो. 21 को 50 days भनेको कति हो अप्सन नम्बर 2. Radioactive nucleus is 50 days. The time interval T2 to T1 between the time T2 when T upon 3 of it has decayed and time T1 when 1 upon 3 of it has decayed is 50 days. को 2 फर्स्टमै एउटै रन त्यहाँदेखि 11 को 2 12 को गरेको छैन, 13 को गरेको छैन, 14 को 3, 15 को अगेन रङ, 3 2 1, 3 2 1, 19 को 1 को 2, 21 को 2, 11 को 2, 12 को 4, 13 को 2, 15 को 4, 17 को 2. The radioactive sample A and B. Again the same question, and you just read it. Decay constant 5 lambda m. Radioactive material A has a decay constant 8 lambda. And B equals to lambda. Initially they have same number of nuclei. At t equals to 0 they have same number of nuclei. How can you do the same question wrong again and again? The ratio of nuclei of A to those of B will be where it is question option number 11, right? After what time? They have same number of nuclei. The ratio of nuclei A to A square. The ratio of number of nuclei of material. After what time? The ratio of nuclei A to those of B will be 1 upon E square after time. After what time the ratio of number of nuclei of material B to A, number of nuclei of material B to A will be. ये तो ratio B upon E किया गया है. I hope you can do it now. It's not even 2. 152. We just have 7 more minutes. Do you want to say anything? But let's talk at 2. I am talking. Okay, say what you want to say. I'm listening. If you are sleepy, you can go and sleep, okay? I know you are waiting for me, but you have class tomorrow. I'm waiting, Gandhar. Say whatever you want to say. Are you there? Gandhar. If you are there, then you can type, okay? I'm just waiting. Yep, say. You want to say something, right? You just said, yeah, talk. Do you want to hear anything? I think you don't have anything to say. I'll just go back to study. NEET UC 2025 application form. Next time you upload your DP, okay? So that I can say the same for you. Gandharva. I hope I'll remember your name. This one. It's 2 not e to the power minus 8 lambda t. Yeah, say. I'm not. Hello, Gandharv. Lambda t. Nothing. Study hard. E to the power 7 lambda t, which is equals to 1 upon e लिखा है उन लोगों ने. lambda t is equals to, ये टाइम ही पूछा गया ना, 1 minus 1. Eleven को 2. So this is how we have to calculate. I don't want to sleep. I have to study so much. वैसे भी मैं अभी अभी तो उठी हूँ. Okay, so say. It's not even. Why are you spamming? It's not 2. It's just 158. I slept at 3-4 approximately whatever time yesterday in the morning, and then I woke up at 5 p.m. No sleep. Okay, Gandharva. Especially you have to sleep, Gandharva, because you have classes in the morning. If you keep on saying like that, then I'll go away. I told you, I'm your elder sister. Sajad, I'm doing physics. हाँ आऊँगी गंधर्वा में लाइव अराउंड 7 के अप्रॉक्स. I hope you are also studying. बोलो गंधर्वा, I'm listening. Angel Gandharva, you are also looking cute. है ना? Now let's study यार. वैसे भी मेरा क्वेश्चन सॉल्व नहीं हो रहा है एक तो. The power obtained in a reactor using uranium-235 disintegrates into 100 kilowatt. The mass decay of per hour is obtained in a nuclear reactor 1000 kilowatt. Upon time. हाँ मैंने भी तो सेम ही किया. Expressed my feelings. You are so small पता गंधर्वा. If we compare our age, I think you are 15 years, right? Both of us has 7 years of age difference. Why are you not studying? लाइव सेशन को तो यही मतलब होता है ना कि you have to study with me. You both are not studying at all. हो गया तुम्हारा सिलेबस तो? नहीं ना, तो और पढ़ो. I don't want to sleep right now, Gandharva. थैंक्स, किसी ने तो समझा, पढ़ लो तो बोला एटलीस्ट। Kinetic energy is high enough to overcome the Coulomb repulsive between nuclei. Sure, kinetic energy is high enough to overcome the Coulomb repulsive force between nuclei. 4. A nucleus emits alpha particle and 2 beta particles. The resulting nucleus is 2 beta negative particle. Alpha particle x m minus 4 n minus 2 plus 4 to n x m minus 4 n minus 2 undergo beta negative decay. X m minus 4 n minus 1 beta negative na 2 beta negative particles. Then this become x m minus 4 n minus 1 beta negative m minus 4 n m minus 4 x n n 25 को 4 two radioactive nuclei P and Q in a given sample decay. Two radioactive nuclei P and Q in a given sample decay into a stable nucleus R. Two radioactive nuclei P and Q. Two radioactive nuclei P and Q in a given sample. Two radioactive nuclei P and Q in a given sample decay into a stable nucleus R. At time t equals to 0, number of P species are and that of Q are and not. Half-life of P for conversion to R. Two radioactive nuclei P and Q given in a given sample decay into a stable two radioactive nuclei P and Q in a given sample decay into a stable nucleus R. Okay. At time t equals to 0, number of P species are 4 and not, and that of Q are and not, Half-life of P for conversion of R is 1 minute. Half-life for P for conversion of R is 1 minute. T half. 1 minute. 60 seconds, that is 60 into 60. 120 seconds for Q. Half-life for Q is equals to 2 minutes. Initially, there are no nuclei of R present in the sample. When number of nuclei of P and Q are equal, initially there are no nuclei of R present in the sample. When number of nuclei of P and Q are equal, the number of nuclei of R present in the sample would be mass of lithium 0.042 mu, less than the sum of masses of all its nucleons. Okay, the binding energy per nucleon del mc square. Okay, 3 proton and 4 nucleon. 6 plus 4 into 1.6. The mass of nucleus is 0.042 mu, less than the sum of masses of all its nucleon. DE 0.042. 931 mega electron volt. Okay, I'll call your name at 7. I'll end the live session, okay? Bye everyone. वही तो सिस्टर के ब्रदर, क्या चाहिए? बोला तो नाम. Bye everyone. You also study, okay? I'll end the session. 0.042 mass into 931. 39.102. 7. 5.5. 5.5. Okay, 5.5 something. 5.5. That is 5.6 mega electron volt. 27 copy. Yep, you can. Bye everyone. I think I can study more peacefully without live session for now. Bye. Study well. Bye Sajad. Bye Gandharva. Yep, Gandharva, you can sleep now.